Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the module SM-350 Kit 1, read data from encoder by using the TIA Portal version 17 and use the incremental encoder model boomer, yes. And in this section, we will read the data from this module. It is the high-speed counter module. So this is a connection of the encoder that connect to this module. And we will go to create the new project step by step and then read the value from the encoder by increase and decrease the value. Okay. And in this section, I will use the LAN cable connect from my PC to the PLC Profinet port of CPU 314C to PN/DP. Yes. Actually, this CPU it has built-in the high-speed counter also for this slot. But in this section, I will just show the example about how to read the data from the FM350 Yes. So before go to create the new project and test with the encoder, I would like to explain about how to wiring the encoder to the PLC. Okay. So let's go. So here is the overall drawing. I just draw with the connection of encoder to the counter module. So this is the model number of counter module and this is the encoder. So we will use 4 terminals for encoder. Yes, I mentioned in this slide here. We use UB plus A, B and 0 volt. Yes. So we will supply 24 voltage to the module to terminal number 1 and number 20, and it will parallel with the terminal number 2 also for the 0 volt DC, and we will use the connection number 5. Number 5 it means that 24 voltage DC. If we would like to use number 4, we can use with the 5 volt DC. Yes. And we will use the A connection. It means that the signal from encoder phase A, and B it means that signal from the encoder phase B. Okay. So we will use terminal number 1, number 2, number 5, number 6, number 8 and number 20. Okay. At the terminal we no discussion. Yes. And we have the function for select with the 5 volt DC or 20 volt DC also. So here if we select D, it means that 24 volt DC, and if we select A, yes, A it means that here. If we select 2 here, it means that 5 volt DC signal. So this one just example. If select D, it means that input 24 volt DC, and here is select A, it means that input 5 volt DC. So in this section I will select D. Yes, select to D. So this is just explain about how to selection the function of hardware configuration of encoder and then how to wiring. And next step we will go to create the new project and then test with the real PLC. Yes, so let's go. Okay, so first let's create a new folder, encoder, and then let's open the TIA Portal version 17. So wait a moment for open the software TIA Portal version 17, and we will go to create the new project step by step and slowly for easy to understand, and read the data from the encoder. Yes, and we can also simulation with the HMI. Yes, I will show step by step. Yes, so let's go to create the new project and put the project name, example PLC, or we can type FM3501 encoder, and then browse to folder that we already created on desktop. So let's go to FM350 TIA with TIA. Yes, and then we can comment this project created for read data from encoder by using FM3501 module. Okay, so let's click create, and then the project will create it after we click. Yes, so wait a moment for creating the project. After that we will go to set up the hardware configuration of the PLC. Yes, okay, so first let's go to project view. Okay, wait a moment for open, and then let's go to device and network, or we can go to add new device. So double click add new device. Yes, and then go to controller, go to SIMATIC S7-300 CPU, and I will choose the CPU that match with my PLC. So 314C 2PN/DP version 3.3, and then click OK. So wait a moment for create the hardware configuration. Okay, and then let's go to add the network. We can check the network property. Yes, go to property, and then we can check the property here. So we have two port of Profinet. Yes, and Profibus. Yes, So right now we use the Profinet, so we can check the IP address 192.168.0.1. Yes. And next step we will go to add the counter module. So let's go to FM counting FM3501. Yes, this one. Let's see the PAN number should be the same here. FM3501AA03. So FM3501AA03. Drag and drop the counter module to the rail. Okay. And it will show the address here. Here is the address. Start from 256. Yes. Until 271. Yes. So this is the address. And then we can zoom. Yes. Okay, zoom to see the overall of module. So we have two parts of Profinet and one part for Profibus, and it is the analog input and output built-in and digital input and output also for the CPU. And we just add one more for counter module FM3501. Yes. So we need to download the hardware configuration to the CPU, right? But before download the hardware configuration to the CPU, let's go to see the counter property. So we need to set some parameter of this counter. So right click on the counter module and then go to parameters. So this one we can select as software get. Yes. And this one we use 0 to 32 bits. Encoder we will use the 24 A plus B. Yes. And we can use the default like this. And for the input we can use default also. Output no need to set, right? So this is just parameter, so we select only 24 or 5 volt. So right now I select 24 volt. Yes, and then save. And then we can compile the hardware configuration. And then we can download the hardware configuration to the CPU. Yes. So let me check the IP address of my PC. We will put the manual of IP address to be the same as with the CPU. Okay, 192.168.0.253. So we can download the hardware configuration. Select here and then click download. So wait a moment for scanning the PLC. So we need to select the PC interface here. I select with the Ethernet connection and then show all capability devices and then click search to search the PLC, because right now I already connected the LAN cable from my PC to the Profinet part of PLC. So right now it detects one PLC 192.168.0.1. I will load the hardware configuration. During load the hardware configuration, we will stop the PLC. So right now the PLC stop and I will restart again. PLC is started. And then we need to create the block for read the data from FM350, right? Okay, so let's go to save the project and then go to blocks, OB1, and we need to create the new block. Example, we create the data block. Example, counter 1. The block name is counter 1. And then we will choose the CNT chain type here, chain type 1. Yes, it means that counter channel 1, channel type 1. Yes, so click here and then click OK. It will create the database automatically. Yes, so we will got this parameters. Yes, automatically from the library. Okay, and then let's go to OB1 again. So I will compile the block first. Okay, no error occur. Error 0, warning 0. And then we need to initial the counter, right? Initial the data block. So right click and then choose the STL network. So I will delete the network 1 first. Okay, we use the static language to initial the block. Yes. So we need to know about the address of the counter, right? The first one. So let's go to check the hardware configuration again. Yeah, this one. Go to property and then check here. It is the address of counter, right? So 256. Okay, and then go to main again. So we can write as L space bar 256. It is the address. And then enter. This one is the name of the counter. So counter 1, name of database, and then dot mode address. Yes, enter. L again. So P 256.0. Yes, and then T counter name. Yeah, counter, and then dot CH address. Yes, here it is the address. L16, and then T counter again, counter 1, yes, dot UD, okay, and then we can compile the program, yes, and save the project. So if we would like to read the data from encoder, we can use one more block. I will add, so this one, initialization the block, and then I will insert the network. This one, read data from encoder, yes. So let's go to library of encoder, yes, and then go to function modules, go to FMH counting, yes, here, and then we can use the CNT one, yes, so drag and drop, okay, we will go like this, or we can use the another blocks that support with the module, yes. So this one dB, I will use dB1 here, yes, so 1. So this one is all is boolean, so I will use M0.0. It is the switch gate, right? SW gate. M0.2. It is the gate STP. M0.3, M0.4, M0.5, M0.6, M0.7, M1.0, M1.1, M1.2, M1.3, M1.4, and this one M1.5, yes. So we can rename the text as OTERRA set DOO set DO1 L direct L PREPAR TCMP V1 TCMP V2 CDOP ARA or SY and C ERES ZERO and the last one is OTERR. Yes, and then we can save and then compile the program. It should be not error, right? So right now we compile finish and then we can save again and then download to the module again. Finish, start the module. And then we need to reset the PLC to let the program is initialized, right? So let me reset the PLC. So wait a moment for turn on the power of PLC. This one maybe I write incorrect. Yes, this one should be 6. Yes, sorry, this one. And then compile again. Yes, we will download again because it is the address of encoder, right? So 256 here. I will download again. And then start the CPU. And then we can online, yes, to see the status. So wait a moment for online. Okay, and then we can go to check on DB1. Yes, we can online to check on DB1. Yes, so let me adjust the encoder and then let's see the status together. I will adjust the encoder. Let me check the status. Let's go to check the hardware configuration again. property. Okay, that's correct, the address. And then let's go to see the OB1, and we need to turn on the switch gate, right? We need to turn on this one, so I will turn on the switch gate. True, yes. And let's check the OB DB1 again. Yes, this one should be active here. Yes, let's see this value, it will work. Yes, let's see the value is increase and decrease. I will adjust the encoder. Yes, so if I adjust the encoder, let's see the signal is increase and decrease. Yes, yes, increase and decrease. Follow our rotate. Yes, so it worked perfectly. Okay, and then we need to show this value on the HMI, right? So we can create the HMI, go to add the new devices, go to HMI, go to HMI. Yes, I will use the comfort panel 7-inch, and then OK. We need to show this value on HMI. Yes, so wait a moment for create the HMI. Just click finish. Okay, so take time a little bit, and then I will delete all this one to put the content, right? I will put the content as FM 3501 read data from encoder using TIA Portal version 17. Okay, I will change background to be another color. Yes, okay. And for this one, I will use rectangle for content. And I will change the color to be this color also. And then change the text to be yellow center. I think 27 21. Yes, let's test 21 first. And before go to see the data here, we need to create some logic or some data to move to the PLC, right? So I will use the, okay, I will outline first. So actual value of encoder so I will convert from double integer to real, right? So instruction, and then I will use the empty, yes, empty box here, and then we can type convert, yes. I will convert from double integer, yes, to real, okay. And then this one should be this one, right? Yes, double integer here. So ACT CNTV, right? So CNT ACT CNTV, okay. And here we can use the memory that we would like to move, yes. Example, I will use MD30, yes. So this is a counter value. Or encoder value. Okay. And then we can save and then compile and then download to the PLC. Okay, finish. So we can online to check the raw value. Yes, right now minus 1060. Yes, if I adjust the encoder, let me adjust the encoder. Let's see the raw value is changed. Yes. Yes, raw value is changed. So we need to show this value on the HMI, right? So first let's go to root screen and we need to insert or add the text for MD30, right? So I will go to connection, yes. Add the new devices. So PLC1 encoder. And then I will use the Ethernet. So 192.168.0.253, it is the address of my PC. And this is the address of PLC, so 192.168.0.1, yes. And then we can go to add the HMI text. So encoder value it is the real, right? Because we already convert from double integer to real. Yes, so MD30. So real, use the divide, and the address is MD30, and we can choose the scan time or cycle time with the 100 millisecond. Yes, so when we update, it will show the status, follow the cycle time that we set. Yes, and then we can go to the root screen. If we would like to show the encoder on the screen, example, we would like to copy the picture of encoder, we can go to copy also. Okay, here is the picture that I already put. Yes, so I will copy the encoder picture to the screen and then paste. We will got the encoder like this. Yes, if we have any type of encoder, we can also copy. Yes, okay, and then we can show the signal of encoder here. Yes, so we can use, actually we can use drag and drop from here. Yes, so we can use drag and drop from the text to the screen. Yes, like this, or we can use the IO file from here. Yes, it is the same function that we can use. So go to property and then go to general and then drag and drop the text here. Yes, and we need to set the format. Yes, so example, the format is this one should be output also, sorry, output only. So example 99999.9. Yes, we will go like this. So this value should be the same. So the first way we can drag and drop the text to the screen, and the second way we can choose the IO file and then use the drag and drop the text to the IO file, and then we can see it. Yes, so here we can go to property, apparent, we can put the color of field to be black, and for text color we can change to green, and the font size, text format, we can choose the center and middle. Yes, and we can adjust the size, yes, of number like this. This one also we can centralize. Yes, yes, So this number should be the same, and we can go to simulation. Yes, but before go to simulation, let's see, make sure we connect the or set the PC PG interface with the control panel. Yes, so go to control panel, go to set PG PC interface 32 bits, and make sure we choose the S7 online step 7. Yes, PLC SIM TCP IP. Yes, because we use the Profinet cable or Profinet port, right? So I will simulation the HMI. So start simulation, and then we can adjust the skin later. It's not linked with the PLC yet, right? Okay, I will adjust this one a little bit. Adjust the layout of this one, and adjust the size to be 17. And I need to go to control panel to check the PC PG interface again. This one correct, right? Okay, choose this one, and then we can go to compile the HMI, and then try to simulation again. Okay, right now we can connect to the PLC. Yes, because the value is shown on the HMI, and then we can test like this. So first, let's make sure the switch gate is turned on. Yes. Okay. So let me adjust the encoder. Okay, we will adjust the encoder. Let's see the value is changed, increase. And if we would like to decrease, we can decrease. Yes. So the value is decreased also. Yes. And the LED is working perfectly. Yes. So it works perfectly for this communication. Yes. So I will delete one screen. Delete this one. Yes, because it is the same. And we can design the screen to be good looking. So first we need to put the switch gate, right? For the switch gate is M0.0. Let me explain. So we need to add the text more for switch gate. The first one we need to put the switch gate, right? So enable counter gate. It is the bool, right? Boolean. And M, it will start from M0.0, right? Here. M0.0. Okay. And if we would like to reset the counter, yes, we need to enable this one, reset for reset, right? This one. Okay, I will insert one more network for reset the counter. This one should be reset value of encoder. So far we need to turn on this bit, right? So M0.5. It is the set DO1, right? And if we push that button, yes, I will move the value. So move 0.0 to the counter, right? So DB1 ACT, right? So we can use this one. Reset the counter. Let's go to see the right value here. Command right? Write the command to counter. It should be right user, right? Right user. Or we can write here. Yes, we can go to right here. DB1. Channel address. Okay, let's test this one. So I will use the M0.5 here, and I will use one more M1.6. This one reset counter, right? Reset encoder. So we can use like this. Yes, we can use like this. And then we can download. Let online to check. Okay, so we can change this one to be counter db1, right? And then choose the load. Load underscore VAL. It is the new load right user, new load value. Yes. And then we can save and then compile the project. And then let download to the CPU again. Yes. And we can online. Yes. So right now the value is 0. Yes. Because M 1.6 is turned on. So I will remove off. Yes. And then we can reset the counter from the HMI. So we can link this one to the HMI. Yes. So go to HMI text. And this one should be reset encoder. So M1.6 100 millisecond also. Yes. Compile the block. Yes. There is no error, and then we can create the push button for enable the counter or enable the encoder and reset the encoder, right? Okay. So first we need to insert the enable encoder or enable the FM, enable switch gate, SW gate, So go to property and then go to apparent, enable. I will use this button and change the text color to be black. Or we can change to be green color. It is the enable switch. And one more button for reset the counter, right? So one button is enable and one button is reset. Maybe I will change to green color. Yes. And this one I change to this color. So normally we will use the red, it means that not yet enabled, and if the green, it means that enable the switch gate. Yeah, so this one should be reset encoder. Yes, and we can go to event and click. So this one we can use invert bit, right? So invert bit, go to HMI, take default, and then we can use the enable. Yeah, this one, enable the counter gate. So drag and drop, and we need to show the color animation also, right? So go to color animation, go to display, insert new apparent, and then drag and drop the text, and we will change the color to be green, right? If the condition is 1, it means that we already enable the switch gate of module. Yes, and for this one we can also go to event and then choose freeze. So set bit when while key freeze, and then I will choose the reset encoder. Yes, so that's all. And then we can test again. Yes, so this one should be, I will copy this text, value of encoder, I will adjust the size to be 25. Yes, change the color to be white. And this one should be reset, enable and reset the counter, right? So enable switch gate, and this one should be reset encoder. Yes, like this. So the picture of encoder we can put here. And then we can save the project and simulation the HMI again. Go to HMI and then simulation. Oh, this one we need to change a little bit, right? The size is so big, the font size. So I will adjust. Adjust this one also. I will adjust the size to be 23. Yes. Okay, good. And then go to simulation again. Okay, so first we need to enable the switch gate, right? So let's go to see the main program and then go to see the switch gate. Right now it's true, right? So if we disable the switch gate, the counter is not working, right? Will not working because it doesn't work with the function without turn off the switch gate. So if I turn off the switch gate, so let's try to adjust the encoder. So let me adjust the encoder. Yes, it will not work, right? Okay, because we not yet enable the switch gate. So if I enable the switch gate, yes, and let's try again. Okay, let's try to adjust again. Yes, the signal is working. Yes, and the value is increased. Yes, if we rotate fast, it will fast. So if we would like to adjust, decrease or reverse the signal, the value is decrease. Yes, increase again. And if we would like to reset the encoder, we can push here. Yes, if we push, this one should be work, right? So if I push, yes, it work. But the value still have, right? So let me check again. Why cannot reset this one? Move 0 to 0, and then the new value should be moved to here, right? This one work or not? Move to 0, right? But the value still have. Okay, right now we cannot reset, right? Because we use the incorrect address here. So we need to put the L direct. Yes, so M0.6. I will change this one to M0.6 and then download again. And let's go to online again. Yes. So let's try to reset the counter again. So I will put reset. The value will move to 0, right? Because we use the L direct to reset the counter. Yes. When we turn on this one should be turned on also. Yes. And then reset the counter to 0. Okay. So if we try to adjust again, let me adjust again. So adjust the encoder again. The value is show, right? Increase. So if we decrease, the value will show minus. Yes. And if we would like to show only the positive number, yes, we can adjust here. I will use the function ABS absolute, yes. And then I will choose the temporary variables. Yes. Example temporary one. It is real, right? So we can choose temporary here. And then absolute the value. Okay, and then we can download. Okay, let's see, it is minus 340, right? And this one 340. So if we would like to show only the positive number, yes, we can use this function. Yes. And we also can reset the counter. Yes. And let's adjust again. So if I adjust the encoder, let's see, the value is changed. Yes. So it worked perfectly. So this is a just example about how to read the data from encoder by using the TIA portal and module FM3501. Yes. So I hope this one just the example for everyone to practice if we have the encoder and we would like to use with our project. So we can use the example to practice. Yes. And then we can use it. Okay. So for encoder, we can use for measuring the speed of motor or check the another function that we can use. Yes, so many options that we can use with the encoder. So if we would like to use, we can follow my video and then we can create more program to use. Yes, so thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I'm also sorry if I have mistake in this video also. And I will drop the example file under my video for easy to everyone download to learn or to see the status how to edit or how to create the program. Okay, so in this time I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will go to learn about how to create the faceplate for control the motors by using the PLC S7-300 CPU 314C 2PN/DP. So here is the faceplate that I already showed the highlight in the previous video. We can start and stop by manual mode one by one, and we also can start stop the group. It means that start stop by using the group. Example, I push the start, it means that the motor 1 will run and then delay time little bit, motor 2 will run, delay time little bit, motor 3 will run, and after that motor 4 will run. Okay, and if we stop the group, the motor 4 will stop, after that motor 3 will stop, motor 2 will stop, and motor 1 will stop. Okay, and we can also select manual and auto mode one by one, and if we select manual mode, this pop-up will not show. Yes, so we need to create the function block. Yes, FB, and we can create the faceplate one by one to control the motors. Yes, so the concept is when we click motor 1, it will pop up for start stop panel number 1. If we push or press this motor, it will pop up the screen motor number 2, number 3 and number 4 also pop up when we click motor number 3, number 4 also. Okay, and then when we push start group, the group will running and then show this signal. It means that group is running, and motor 1, 2, 3 and 4 start step by step. Okay, so I will use PLC S7-300 model 314C 2PN/DP and use the Profinet port. Connect to my PC that already installed GIA Portal version 17. Okay, so this is just the concept how to start stop the sequence of motor, and also create the basic faceplate. Okay, so let's go to create the project and then create the faceplate and control the motor step by step. Yes, so let's go. Okay, I will use the TIA Portal version 17. Yes, so I will create a new folder. So sequence start stop. Okay, and then go to click the TIA Portal version 17. Yes, and then we will go to create the project step by step together. I will go slowly in this section because need everyone to understand about how to create the project, how to create the function block, and how to create the pop-up or faceplate. Yes, so let's go slowly with me. Okay, so next we can create a new project. I will put project name start stop motor and browse the folder that we already created here. Yes, this project create for start and stop the motors by sequentially. Okay, so click create to create the project. So take time a little bit for create the project. And then go to project view to create the hardware configuration. Okay, so go to add new device to add the new CPU. Go to controllers, go to SIMATIC S7-300 because right now we use SIMATIC S7-300 CPU 314C 2PN/DP here, and then OK. So wait a moment for create the new devices. Okay, so right now we already created the CPU. Yes, hardware configuration. So CPU 2314C 2PN/DP here. Yes. And then we can go to check the property for check the Ethernet IP address. Okay, so the address of the CPU is 192.168.0.1. Yes, so I will set my computer IP address with the same rank of the PC, sorry, the PLC. Yes. So I will put 192.168.0.253. Yes. And then we can download the hardware configuration to the CPU, right? So I will go to compile the hardware configuration before download. Okay, there is no error, right? Then we can download the hardware configuration, yes, to the CPU. So I will push download to device. And then choose the Ethernet driver. Yes, my Ethernet driver is Intel A2574L gigabit. Yes, and then we can push the start search to search all devices. It will automatically detect one device. Yes, that has IP address 192.168.0.1, and then we can click load to load the hardware configuration to the CPU, and then I will stop all to stop the CPU, and then start the CPU after download it. Yes, right now the CPU is running. Yes, CPU was started, and then we can go back to our slide. Yes, so we need 4 motors, right? Motor 1, motor 2, motor 3, and motor 4. So the platform is the same. Yes, let's see. The platform is the same. So we can create only one. Yes. And then the motor has start, stop, status, manual, and auto mode, right? And also the status, we can use the same here. So we can create the function block. Yes, go to blocks, program blocks, and then go to, if we zoom a little bit, go to add new block, double click. Example, I will use MTR. It means that motor block. Yeah. MTR PLK motor block. And then I will choose the ladder language and choose the function block. Yes, here. FB, and then click OK. Okay, we will got the new blocks here. FB1, yes. And then we need to assign the parameter to the block, right? So we have start, stop, manual, and auto mode, right? So I will assign the input with start. It is the boolean, right? And start command. Yes. After that, stop. Boolean also, stop command. After that, we have auto and manual mode, right? So I will use only one bit or 1 point or 1 take with the auto manual mode. Then I will use mode select. Yes, mode select. And when select mode select, it means that when 1 we have 0 and 1, right? 1 it means that auto, and 0 it means that manual. 1 auto mode, 0 manual mode. Yes. After that we have output, right, for run the motors. Yeah. So I will use one output. So output here I will use drive. So the data is boolean, and then this one command run, command start motor. Yes. Okay, so we have 3 input and 1 output. Yes. Then we can create the block interlocking. Yes. So first I will check the auto and manual mode first. So this one mode manual. So manual mode is 0, right? So I will use NC for manual mode. So when not select, it means that manual mode. Then we can start. Oh, we need to put one more command, right, for start auto. Yes, start auto. So command start auto. Okay, so we will back to our network. I will select manual mode, and then we can start. And I will put the button stop here, and then we can stop. And the output will dry, right? So I will use output for dry. And I will hold the signal. Yes. So I will hold the signal. Sorry. Hold the signal by dry, right? Okay. This is the manual mode. So when auto mode, yeah, then we can put here. Manual mode is already created, right? So we need to use the auto mode. It means that start the sequence command. So when select auto mode, then we iterating the command from the auto mode, right? Auto start. And then we'll turn on the output also. Yes. And then I will put one more for motor overload. It will trip also, right? Yes. Motor overload, it will trip. So I will use NC and then use the motor overload signal. Yes, to protect the motor, right? And when motor overload, we need to reset the alarm, right? So this one, start command, start stop command, manual and auto mode. Then we have command clear alarm, right? Clear alarm. Yes, clear alarm. So when motor overload, command clear alarm. So when motor overload, then I will use one more for motor alarm. For output motor alarm. Yes. So I will set the motor alarm. Motor alarm here. And then here I will use motor alarm. Yes, to cut off the motor. And then we need to reset the alarm, right? When the motor is cool, yes, then we need to reset the alarm before we can run. So I will use the reset alarm and then reset the bit motor alarm. Okay. So this one should be clear command clear alarm. This one motor overload signal. Okay. So let's check again. When the select manual mode, we can start and stop by manual. And then when the motor alarm, it will trip the motor. Yes, because we use NC. And when we select the auto mode, we need the command start auto from the input, right? Okay. From here. Start auto, yes. So that's all. We can save the project and then compile the block. Okay, so there is no error. Then we can close. And then we can close also. And go to main OB1. So this one for motor number 1, right? So motor motor 1 control. Okay, then we can drag and drop here, drag and drop the FB1 to the network, and then we can put motor 1. Yes, it will automatically create the database data block. Yes. Okay, so %db1, and then we have start, stop, mode select, start auto, motor overload, and command clear alarm, right? And we have two output. The first one is dry, the second one is motor alarm. Okay, and then we can put the address, example M0.0 for start manual, M0.1 for stop manual, M0.3 for selection, M0.4 for command start auto. Motor overload, I will use I, right? So let's go to check the I. Go to device configuration to check the input. Yes, here. I/O address, it will start from I136.0, right? So I will mark as motor 1 overload, motor 2 overload, motor 3 overload, motor 4 overload. Okay, and then for the output we can also remark, yes, here. Example motor 1 dry, motor 2 dry, motor 3 dry, motor 4 dry, and then motor 1 overload or motor 1 alarm, motor 2 alarm, motor 3 alarm, motor 4 alarm. Yes, then we can compile. Okay, and we go back to main OB1 again. So this one I will use motor 1 overload. Yes, motor 1 overload. Yes, here it will link automatically because we already created the symbol, right? Symbol name. And for clear alarm command, I will use M0.5. And this one I can use motor 1 dry. And this one I can use motor 1 alarms. Yes. And then this one we can rename as start M1. Stop M1. M1 selection. M1 select mode. This one start M1 start auto. Okay, and then this one clear alarm M1. Yes, then we can save, and totally we have 4 motor, right? So we can copy this one, motor number 2, and then we can drag and drop the BLK to the network, and then put the name motor 2. Yes. Okay, and then I will start from M0.6 M0.6, M0.7, M1.0, M1.1, motor 2 overload. Then this one M1.2, this one motor 2 dry, and this one motor 2 alarm. Yes, and then we can rename to be start M2, right? Start M2, stop M2, start M2, stop M2, M2 select mode, M2 start auto, and this one M2 clear alarm M2. Yes. So formula number 2 we already created it, and then copy formula number 3. Okay, and then drag and drop the block to the network again, and then put the name of motor 3. Okay, and then I will start from M1.3, M1.4, M1.5, M1.6, motor 3 alarm, motor 3 overload. This one M1.7, this one motor 3 dry, and this one motor 3 alarm. Yes. So actually we can go to the PLC tech, and then we can also rename here also. Yes, example, we can rename here to be the same as the block. Yes, but here we can adjust and rename also. I will rename as start M3, stop M3, select mode M3, M3 start auto, right? M3 start auto. Yes. And this one clear alarm M3. Yes, and the last one is motor number 4, right? So we can copy again, paste, and change this one to 4, and then we can drag and drop the block again and put the name model 4. Yes, and then I will start from M2.0, M2.1, M2.2, M2.3, sorry, M2.3, 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 this one, M1, model 1, this one model 4, overload, and this one M2.4, model 4, dry, and this one model 4, alarm. Yes, then we can rename the tag as model 4, start model 4. Actually start M4, right? Start M4, stop M4, M4, select mode, M4, auto start, and then clear alarm, M4. Yes, so that's all to create the block for motors. Yes, then we can save the project and then compile the program. Yes, there is no error, right? Then we can download again. Yes, I will stop the CPU again because we just create the new block. Yes, so finish. And then we can online to check the status. Yes, this one initial, right? I will modify to 0. Put this one to 1 to stop, right? Okay. Okay, so right now we already create the block. Then we go to create the faceplate. So I will go to add the new device to create the HMI. Yes. So wait a moment for create the new HMI project. And then we can go to create the pop-up or faceplate together step by step. So I will click finish. Okay, the project of HMI will creating. Yes, then I will delete this one, delete this one, delete this one, and I will go to offline first. After that we can online again. Yes, So here we can go to change the background of the HMI. Yes, change the background of the HMI, and then we have 4 motor, right? So first I will create the push button, or we can put here, put the rectangle here. Okay, we can put like this, and then we can insert the button, right? So I will put start, and then copy for stop, and we have manual, and we have one more for auto, mode, manual mode, and we have one more for clear lamp. Yes, and then I will extend the button, like this, and we need to insert the motor, right? So I will insert the motor here, or we can put like this. Okay, we can put like this, otherwise we cannot put the motor, right? Okay, I will put like this. Okay, like this, and we need to show the status of the motor here. When run, it will green, right? And then we also show the status of the motor here. So we go to property and then change this one to be green. Sorry, red. This one should be red also. Yes. And then for the start button, I will select with the solid and then change for blue, and for the text I will change to be black, and for stop I will change also to solid, and then change to red, and this one should be black. For mode select I will use this color. This one also no select, it will choose. I will choose this color. yes. And for command clear lamp, I will use this color. Okay. And for the background, I will change to be this color. Yes. And I need to put one more button for close the screen or close the faceplate. Yes. It should be like this. Okay. And then I will change the color to be red color because we close the screen, right? Okay. Like this. And then we need to put the name of the motor, right? So the name of the motor I will put here. Motor 1, motor 2. Okay. Maybe I will adjust this button to smaller than, because the space is very small, right? Okay, maybe like this is okay. Then I will put the name of the motor to be motor 1. Okay, motor 1 here. Then we can adjust the layout. Align to be center, yes. And then here we can adjust to be bigger than. Okay. So for the screen, we can design the style, another style that we want. Yes. So I will focus only configuration for the push button and HMI. Yes. Okay, like this. Then we can simulation to check the screen a little bit. It's okay or not. Okay. So that's good for push buttons and for the screen. Yes. And the concept is when we push when we click here, it needs show this pop up, right? So I will use one more button. Yes. And then put like this. And then I will delete this one. Yes. Okay. And then go to property and then go to field and then choose the transparent. Yes. When we put like this, it means that here, yes. So here we can also adjust to 0. Yes. And for this one, actually we can adjust to be bigger than the motor a little bit. This one I will choose 0. Yes. Okay. So we can set up only one motor for test first. Yes. Okay, so let's go to create the tag. HMI tag. But before go to create the HMI tag, let's create the connection. PLC1 and choose the driver as S7-300 400 station, and then choose the Ethernet, and for the IP address 192.168.0.253 192.168.0.1. It is the IP address of PLC, and here is the IP address of my PC. We can also check IP config. Yes, 192.168.0.253, and then go to HMI tag. Yes, then we can create the tag. So we have motor 1, start M1, stop M1. Yes. Actually we can copy and paste from here. Yes, so let's copy and then paste. Copy, and then we can also create one by one. Okay, let's go to create one by one. So M1, start M1. It is the boolean, right? And choose the device for PLC1, and then I will start from M0.0, right? Because the same as the PLC tag here, M0.0. So M0.0, and change this one to 100 millisecond. And next we can insert for stop M1. The address will generate automatically. Yes, here. So next M1 selection, right? M1 start auto or M1 selection. Let's check here. Manual mode selection. It means that M1 selection mode. M1 selection mode, and then next M1 start auto, right? So M1 start auto, M1 start auto is M0.3, yes. And next go to M1 overload, right? But we can create the I first because it very easy to create here. I will create the clear lamp M1. Yes, M0.4, that's correct, right? 0.0, 0.1, 0.2. Oh, this one it jump 0.2, right? Okay, no problem. I will rename this one to be M0.3. This one M0.0, M0.1, M0.3, M0.4, right? So M0.3, M0.5, we jump the address M0.2, right? M0.4, M0.5, yes. And next we can copy and paste. Select copy and then paste. Yes. And then change this one to be M2. Stop M2. M2 selection mode. M2 start auto. Clear lamp M2. Yes. And then we can go to change the address here. Yeah, don't forget change the address. So this one should be M0.6, right? So M0.6, M0.7, M1.0, M1.1, M1.2 until M1.2, right? Here. And then let's go to model number 3. So we can start from here. Yes. So right click and then copy. Right click and then paste. And we can change the name to be M3. Start M3. Stop M3. M3 selection mode. M3 start auto. Clear lamp M3. Yes. And for the address, it will start from M1.3 until 1.7, right? So this one should be 1.3, 1.4, 1.5, 1.6, and 1.7, right? Okay. And we will copy for model number 4. Right click, copy, right click and paste. Yeah. And change this one to be 1 to 4, from 3 to 4. M4 selection mode. M4 start auto. Clear lamp M4. Yes. And we need to change the address. Yes. Also from here. So let's go to check the M4. It will start from M2.0. So it will start from M2.0, M2.1, M2.2, M2.3, M2.4. Yes, M2.4. So that's all right. And then we need to create the input for overload. So M1, model 1 overload. So M1 overload. The address will start from I136.0. So I will choose I136.0 and then M2 overload automatically address. M3 overload and then M4 overload. Yes. And next we will create the output, right? Output, it will start from Q136.0, M1 drive, M1 alarm. Yes. So M1 drive, it will start from Q136.0, M1 alarm, M2 drive, M2 alarm, M3 drive, M3 alarm, M4 drive, M4 alarm. Yes. So until Q136.7, right? So let's check to confirm. Yes. So that's correct. And then we can compile. Yes. We can save and compile. Okay, there is no error, right? Then we can go to create the faceplate. Yes. Go to our screen and then go to configure the button. So the first one, I will configure the start button. So right click and then go to events, go to freeze, and I will choose the set bit while key freeze. Okay, so we will configure the start button, yes, by using the set bit while key freeze, and then we can drag and drop the text for start M1 here, yes, and for the stop we also use the freeze and then choose the set bit while key freeze, and then choose the stop M1, yes, and for the manual and auto mode we can go to manual. Auto mode, it means that we can select, right? So I will use freeze, and I will use the set bit, right? And then I will use the selection M1 selection, right? M1 selection mode, yes. And when we select the mode, auto mode, it will display or it will show the status, right? So I will go to animation and then go to display, create the new animation apparent, and change, and then choose the mode select and change the color to be green, right? Yes, like this. And then for this mode we can also choose the color apparent, and then when condition 0 I will change to green, yes. And then clear the alarm, right? Clear the alarm, we can use the event and then choose freeze and then clear the M1 alarm, right? So set bit while key freeze and then clear alarm M1, yes. And we need to show the status of the motor 1, yes. So we can go to color animation, insert the new apparent, and then go to M1 drive, yes, here. And then choose the condition 1 and change the color to be green. And this one also, yes. So the normal condition is red, so I will choose the color animation and then change the M1 drive to 1 and then change to the green color, right? Change to the green color, yes. And for this faceplate for this object I will put the same position, yes. So that's all, and then we can configure this one later. So we can simulation first, so I will online this one and then go to OB1, can online, yes, and we can simulation here. Okay, so here is the mode auto, right? Sorry, mode manual mode, right? So we can start the motor. We need to set the PC PG interface. So I will go to control panel, and then go to set the PC PG interface. Go to S7 online, step 7, and then choose the correct driver that we already connect, right? And then let simulation again. Yes. Okay, the connection is working. Then we can select and see the condition together before go to the step 2. So mode manual, mode auto, mode manual. Oh, this one should be reset, right? So we can go to change the screen selection. This one we can go to events and then choose the preset and then choose the reset bit and choose the tag, choose the reset bit, right? M1 selection mode. Yes. Then we can save and then simulation again. Okay, and then go to OB1 again to see the condition. Okay, I will try to select again. Let's see this one. Yeah, fall. So we can start the motor. Yes, motor is running. So the condition will change to green. I will stop the motor, start again, stop again. Yes. Auto mode. Yeah, let's see this bit is work. And we need to configure the clear alarm. Yes. And configure this button also, right? So I will change the take default to be 100 millisecond all for all take. Yes. Because it if we not change this one, the condition will slow, right? Okay, I will change to 100 millisecond for all takes. And then let's go to back to our screen to configure the clear alarm, right? So clear alarm we already set, right? Okay, and we need to configure this one. When we not click this one, it will not pop up, right? So we can go to events, go to preset, and then go to set bit, and then we can create the new text internal text. Yes, I will add new text. Example, take name M1. Yes, and choose the boolean here. Yes, so the internal text is M1. Then I will configure this one. go to events, then go to freeze. I will reset with M1. Yes, and for all pop-up this page I will show it when I only freeze this area, right? Freeze the M1 area. So we can go to hidden, yeah, by using the animation. Go to add new animations, goes to visibilities, and then we can choose take M1 that we already created internal tag, and choose the rank from 0 to 0, and then use invisible. Yes, so we can change all the same. Yes, go to animation, add new visibility, choose M1, and then change from 0 to 0, invisible. This one also. Go to property, add new visibility, M1, 0 to 0, visible. Yes, this one also, add new visibility, M1, 0 to 0, visible. Yes, we can do the same procedure. From 0 to 0, M2, from 0 to 0. We no need to show the status, right? M2, sorry, M1. This button also create the new visibility, M1, change to 0, visible, visibility, M1, from 0 to 0, visible. Yes, so that's all. Then we can test the screen again, simulation. So let's see, it not show the status, right? So when I push here, yeah, it will show, and click here, close. Yes, and then we can start, stop, yeah, auto, manual mode. Yes, clear the alarm. Yes, start, and then we can close. Okay, so we can do the same motor 1 to motor 2, motor 3, and motor 4. Yes, so this one is very easy, so we can copy. Okay, right click, copy, right click, paste, and we can drag and drop. Yes, and we can right click, paste, and one more, right click and paste, right? Maybe we can zoom a little bit. Maybe delete this one first, then we can drag and drop. We can adjust like this. So we need to put the play for start stop group also, right? So I will copy again, or we can paste again. Okay, and then we can adjust a little bit more. Multi-selection, yes. Okay, like this. We'll adjust a little bit for the rectangle. Okay, maybe like this, okay, right? Then we can change the name to be model 2, model 3, model 4. Yes. We can align and design the same, the style that we want. Yes. We can choose any style. Yes. Then we can save the project. And we need to change the name to be a model 2, right? So for this one, I will go to events. Please change this one to create the new for M2. Boolean also, yes. And then change this one to M2. Okay. And for the status, this one, I will change color animation apparent to be M2 dry. Yes. And we can put this position again. Okay. And we need to change step by step from the button. Yes. This one we have two options that we can change. The first one is visibility. I will change to M2. And also events, change to M2 also. And the next step, we can go to animation, change this one to M2. This one also change to M2. And color animation, we can change to M2 dry. Okay. And the background, we can change to M2. For start button, I will change to M2 also. And event, I will choose start M2. For stop, I will stop M2. And animation, we can change to M2. For mode selection, we can change to M2. Events, we can change to M2 selection mode. This one also change to M2. So we can create the text as to be similar, otherwise we cannot put like this. Yes. So animation, I will change to M2, and this one I will change to M2. Events, I will change to clear alarm M2. Yes. So that's all for M2, and then go continue to M3. So M3, this one we can go to events, create the new. For M3, Boolean also, yes. And then I will adjust a little bit, and then go to animation, change this one to M3 dry, yes, and then put back to be the same as the position. Yes, and go to model M3, and then visibility I will change to M3. This one also visibility M3, and also events change to M3. Yes. The background animation change to M3, and the status of the motor run I will change to M3. And apparent I will choose M3 dry. Yes. And start button visibility M3. Events change to start M3. Yes. This one stop M3. Change the animation to be M3, and the manual mode we can change to M3. Events change to M3, and also color animation we have apparent also, so change to M3. Yes, this one also change to M3, and then visibility M3. Events M3 also. Maybe this one we should change also, right? So I will change this one first. This one is M3. Go to animation, no, M3, right? Okay, and then I will recheck this one again. This one apparent should be changed to M2. This one also apparent change to M2. For event, that's correct, right? Okay, correct for events. Okay, good. And then we can go to M4. So I will go to M4 and then go here, create the new text, add new. I will choose M4. Then I will change this one to be M4 drive. Yes, and then put this one to be back to original position. Okay, then go to the top. This one should be changed visibility to M4, and this one should be go to M4. Events, freeze, change to M4. For this one, we already changed, right? Okay, and then we can the background to be M4. The status I will change to M4 also. Event, no event, right? But color animation we have also apparent. Change to M4 drive. Yes, this one M3, okay, M2, M1, right? Okay, that's correct. And then we can go to start button, visibility, change to M4, events, start M4, right? Stop also, stop M4. For animation, we can change this one to M4. Manual mode, we can change to M4. For the apparent, we also change to M4 selection. And event, we can go to freeze and then change this one to M4. For auto mode, change this one to M4. And then change the color animation to be M4. Visibility, change to M4 also. Yes. And the last one, for clear lamp, I will change to M4. And events, this one should be clear lamp M4. Yes. So that's all. We can save the project and then we can try to simulation again. Yes. Any confused or not? Yes. So we can simulation. Okay, that's good. And then we can go to main. And we need to check one by one, right? Okay, so I will click. Okay, pop-up will appear. Then we can start. This one not work, right? Oh, this one confused. So we can go to check the events again for motor M2. Start M2, go to events. Please start M2. Stop M2. That's correct, right? So we can go to check on the OB1. Yes. Why it's not work? Motor M2. Motor M2 is already on, right? But the condition is not on. So we need to check the color animation. I will try to stop. It stopped. Start again. It start, right? So let's check Q136.1. Yes. Go to the root screen, then check the color animation. This one should be changed to M2 drive, right? M2 drive already created, but we need to see the tag, right? M2 drive, this one. Oh, M2 drive should be the address is not correct, right? M1 drive 136.0, 136.1, M2 drive. Okay, let's check the address again. Q2, this one. Model 2, right? Q136.1. Okay, let's check the HMI tag. This one should be .1, right? M1 drive .0, M1 M2 drive .1, M3 drive .2, M4 drive, M4 drive .3, M1 alarm .4, right? M1 drive, M1 alarm .4. Yes, here Q136.4. Sorry, it confused here. I confused here. So this one .4, M2 alarm .5, M3 alarm .6, M4 alarm .7, right? M4 alarm .7, M3 alarm .6, M3 alarm .6. Okay, so .0, .1, .2, .4, .5, .6, .7. Okay, that's correct. And then we can simulation again. So let's go to check the model 2 again, right here. Okay, the condition is okay because I compute the address. Yes, sorry. Then we can start the M3, M4 also start, right? Then we can stop one by one. Yes. And let's see the output on the PLC is working. Yes. Yes. I will show the status on the PLC. Yes, when I push the control on the HMI. So let's see, the condition on the PLC is turned on, right, for the output. So if I stop, example, I stop motor number 1, stop motor number 3, stop motor number 4, stop motor number 2, start again, 1, 2, 3, 4, yes, so it worked perfectly. So this is just manual mode. Then we can create the auto mode, yes. So I will close the simulation and then go to outline first. And then we can create for the automatic mode, right? When we start the groove, yes. When we start groove, the motor will start step by step, yes. From motor 1 to motor 4, and when stop from motor 4 to motor 1, okay. I will go to root screen and then put the title here. Change the color to be, go to property, I will change this color, insert the text, create TIA Portal version 17, create FB, yeah, function block for control motors, control for motors, and then we can go to layout and check this one, and I will change the color to be yellow like this. Yes. Then we can simulation, yes. Okay, good. So when we don't push the motor, it will not show the pop up, right? Okay, we can start, close and open again, yes. Then okay, I will stop the motor first. I will stop first. Maybe I will put this one to be 17, yes. So we will create the group for start and stop, right? Okay, I will create the new network. Create the group start and stop for all motors, step by step. Okay. So for the group, we need to select all the motor to be automatic mode, right? Okay. So I will choose the NO for motors. Okay, and then one command for automatic mode selection. Yes. So first I will copy from this one. Yeah, we can copy and then paste here. This one also copy and paste here. We need to end, right? Because we have 4 motors. So if we would like to start with the group, we must select all the motors to be automatic mode. Yes. So I will copy, paste, and also copy, paste. Yes. So motor 1, motor 2, motor 3, motor 4, all must be selected to auto mode. And then I will generate M 10.0. Yes, this one for automatic mode selection, right? All motors auto. Yes, post auto select. After that we need to create the button for start and stop group, right? So I will add new network. This one should be group selection. Group selection to automatic mode. Yes, and then I will create more for stop and start the group, right? So when all motors select to automatic mode, so I will copy and then paste here, and then I have start group, example M10.1, M10.2, M10.3. Yes, then I have stop group. Yes, and I have also start group. And then I have group started. Yes, and I will hold the signal when group started. Sorry, I will choose this one, and then I will hold the signal when group was started. So copy and then paste. Yes, and when group was started, right, I need to start the motor M1. Yes, so I will delay time little bit when group started, because we need to connect to the alarm the siren, right? Yeah, to let the human know about how group the machine is running. So I can insert one for timer. So when group is running, I will insert. So copy and then paste, and I will insert the timer. Yes, so TON. And example timer 1. Yes, I will delay around 5 seconds. Yes, so T sharp 5 seconds. So I will turn on. Yes, turn on M 10.4. Yes, and then insert one more network. So when M.4 is on, yes, I will hold the signal. Yes, I will hold the signal. So I need to put M 10.5 for hold the signal. Yes, and then actually we can copy from here for start auto. Yes, we can copy from here and paste here, or we can paste here. Yes, yes. So when timer is turned on action, then this one is turned on, this one is turned on also, and then copy this one. Yes, to paste here. Sorry, paste here for model 1. Yes. So when timer on action, then this one turn on, this one is turned on also, and then hold the signal by this one, and this one will start the command for model 1. Yes, and for model number 2 I will insert one more network, and then I can use command from here. But it should be select to manual first, sorry, auto mode first, right? Okay, then I can use one more and then interlock with the group selection. Yes, so copy and then paste here, and I need to hold the signal also. Sorry, this one is turned on, then I will let the timer. Yes, I will let the timer is turned on. This one we can put the timer, right? Okay, I will hold the signal. I will put the timer 2, right? TON timer 2. Then I will delay around 10 seconds, so T sharp 10 sec. Then I will hold the signal M0.5 10.5, right? I will start from M0.6 M0.6 sorry 10.6. I will compile. There is no error, right? Okay, no error occur. Then I will insert one more network. Actually, we can copy like this, copy and paste, and this one should be changed to this one, right? Okay, so copy and paste this one also, and then I will hold the signal. Hold by this bit, right? Okay, so this one I will change, yeah, copy and then change this one to be start auto, right? M2, and we can do the same as procedure. Insert the network, and then yes, auto mode selection, right? So copy and paste, and also use command from here, right? So insert and then copy and paste, yes, and we need to turn on the timer, right? So let me on the timer. So TON and then timer 3. I will delay 10 seconds also, yes. Okay, and then this one I will use command from here, copy and paste, and we need to insert one more network, yes. So this one turn on, then I will turn on this one and choose one more for M10.7, right? So M10.7, and then I will hold the signal also, yes. Hold the signal, copy and paste, and then I will paste here also, yes. Okay, so this one will start motor 3, and for motor 3 I will insert one more network and then copy from here, automatic selection, paste here, and then insert here, insert command from motor 3, and then turn on the power, turn on the timer, TON timer 4, yes, this one timer 3, right? And this one timer 4, then delay time 10 seconds also, and I will turn on this one, copy this one, and then I will insert one more network for hold the signal, right? Hold the signal by this one. So this one I will choose M11.0, right? M11.0. This one also M11.0 because it holds the signal, right? And then we can copy from M11.0 to control the start auto for motor 4. Yes. So that's all for group start. Then we can test for group start first. Okay, so first we need to show the status of group selection, and then we need to create the HMI for group stop and group start, right? Okay, so I will download the logic to the PLC first. Download. Okay, finish. Then we can online. Okay, so if we go to simulation, yes, let's go to simulation and then try to select two auto mode. Okay, we can select one by one to automatically mode. And let's see, this bit will turn on, right? I will select to automatically mode. Yes. Yes. So we need to show the condition here. The mode selection is okay, right? Okay. So we can go to create the HMI. So first let's go to the text. We need to create the text more, right? So the first one is group status, group selection status, right? M10.0. Group selected. I will use the PLC device, and then the address will start from M10.0 and change this one to 100 millisec. Okay, and the next step we need to create the group stop, right? M10.1. So group stop M10.1. Change this one to be 100 millisec also. And then group start. M0.2, 10.2, sorry. And then change this one to be 100 millisec. Yes. So group start, group stop, and group run, right? Group status. So group status M10.3, group status M10.3, and then I will change this one to be 100 millisecond. Yes, then we can compile the text. Okay, there is no error occur, right? Then we can go to the root screen. Then we can create the more faceplate here. I will create with the small for start and stop group. Yes, because we have small space, right? Okay, like this, and I will change the color to be, go to property, go to apparent, change to this color, and then we can copy from here, paste. For close the faceplate or close the pop-up, right? And then I will choose the button for stop. And then copy for start. So we have start and stop, right? For group. Actually, we can put like this. The same as this one, and then we can adjust. Okay. So this one should be start. I will change the text to be like this, and then change the font to be like this. Yes. Okay. Save, project, and then I will put color to be solid, change to blue also, and this one I will change to solid and change to red. Okay. Okay, just like this to be aligned with this one also. So we can design another style that we want. Yes. Okay. And I should be have the status of group running, right? Okay. So I will change to be, okay, red color. It is status when group stop, right? Okay. Then we can configure the start and stop group. Yes. So right click for stop and go to events. Go to preset, and then I will choose set bit val keep preset, and then go to default take, go to group stop, group stop, right? Okay, group stop here. And for start, group start, I will insert the function also. So set bit val keep preset, and choose the group start, sorry, this one. And for group status, I will go to animation, new color animation, choose apparent, and then group status, and I will change to, when status 1, I will change to green. Yes, and we need to show only when all the motor select to the auto mode, right? So we have group selection here. Yes, so this one I will config with the color animation, go to new, and then choose visibility, right? And then go to group selected from 0 to 0, and then choose invisible. This one also new, visibility group selected 0 to 0, invisible. This one also new, visibility, and then this one 0 to 0, invisible. The background also visibility group selected 0 to 0, and then for this one I will close the pop-up, right, when we would like to close. So I will reset the bit. Normally we no need to close, right? This one no need to close, because when we select the menu mode, this one should be closed, right? Okay, no need. So I will put only start stop group, right? Can write group, go to property, go to layout, and then uncheck this one, change this one to center, and then I will adjust font to be, yes, 15. Then the color text we can change to be this color. Yes, then we can save, and we can simulation. Yes, okay. Oh, this one should be hidden also, right? I will hidden. Okay, go to color animation, and then go to new, visibility 0 to 0, invisible, save again, and then simulation again. Yes, okay, let's start the group, and then we need to create the stop group also. Yes, so I will go to the OB1, and then simulation. Yes, okay, so right now the group is ready to start, right? Because all the motor we already selected to auto mode. So if I select one motor to manual mode, let's see, we cannot start, right? Because we already config for hidden the start group, because all motor must be select to auto mode. Yes, so we try to select the auto mode, then group will pop up. Yeah, if one motor select to manual, we cannot start group, right? Okay, so I will try to start group. Yes, group is running, so wait timer for start motor number 1. Okay, motor number 1 is running. Wait for start motor number 2. Running for motor number 2. Wait timer for start motor number 3. Running. Motor number 4 is running also, right? So for start group, we already put the correct function. Yes, let me try to select and config for stop group. Yes, so I will close first, and then we can offline. Okay, so we will create the program for stop groups from the motor 4 to motor 3 to motor 2 and to motor 1, right? So we can, okay, I will comment this one little bit for start motor 1 with auto mode. Yes, and this one we can copy and then paste here. Start motor 2 with automatic mode. This one start motor 3 with automatic mode, and this one start motor 4 for automatic mode, right? Then we need to create the stop group command, right? Stop group command. Okay, so for stop group command we need to use this button, right? So I will copy. When we stop group, I will paste here and then change to nominal open. So when stop group, I will set the coil. Yes, set one coil. This is for command stop group. Then I will choose M11.0. I will choose M11, or I will choose M12.0 command stop group. And then I will use this one for hold the timer, right? So first, when we stop group, we need the timer a little bit more, right? Okay, I will use TON. So timer 5. Okay, I will delay time around 5 seconds also. So T sharp 5 sec. Then I will stop the motor number 4, right? So when the timer is turned on, I will turn on one more bit, M12.1, and then I will copy to turn off this one, right? Turn off this one, and then this one will turn off. Yes. And then I will delay time more. Yes. So I will choose the same command stop, and then choose one more timer. So timer 5 6, right? I will delay 10 seconds. Yes. Then I will insert one more bit. So M12.1, sorry, M12.2, and then I will turn on this one to let the M3 is turned off, right? Okay. And one more, we can copy and paste and insert one more timer, TON, timer 7, T sharp 10 seconds, and we insert one more, M12.3, copy and then paste here for stop motor number 2. Yes. And one more. Copy and paste and insert one more timer. So timer age, I will choose T sharp 10 seconds, and then M12.4. Okay, copy and go to cut the motor M1, right? Here. Yeah, sorry. Okay. And then for when the timer is turned on, I will reset all. Yes. I will reset all. Reset this one also. Yes. I will reset all output. So when T or when M12.4 is turned on, M12.4 is turned on. Then I will reset the command stop, right? So I will reset the command stop here. Okay. Then we can test together. Yes, I will download this logic to the PLC and then we can try to test together. If any mistake, we can revise. Yes. So we can online. Okay. Then we try to stop group. Okay, let's try to stop group. Okay, let's try to stop group with the timer for stop M4, right? And then with the timer for stop M3. Oh, this one not yet correct, right? So we need to revise the logic again. It should be stop step by step. Hold the signal, yes. Okay, right now it stopped together with motor 1, 2 and 3, right? So we need to adjust the timer. Yes, I will adjust the timer here. For command stop, motor 1. This one I will change to 15. And this one I will change to 30 seconds. This one I will change to 45 seconds. Yes. And then let's save and then download to PLC again. And let's try to test together again. Because the timer should be not the same, right? Because we use timer on. Okay. Let's try to start again. Okay, we start group again. Motor 1 running. Motor 2 running. Motor 3 running. And motor 4 is running, right? Then we try to stop. If we push stop, okay, the command stop will running. Then set this coil. Yes, I will explain. It will set this one, right? And timer will count. Yes. So if I push stop, this one will set. Okay, red stop. Okay, let's see here is set. Then the timer will working. And then wait the timer for stop for motor number 3. Okay, and then wait the timer for stop for motor number 2. Yes, okay, and wait for stop for motor number 1 and then reset this coil also. Okay, so reset all and then we can start again. Yes, so the group will run again. Yes, follow our right the program. Yes, okay, so wait for motor number 4 is running. Yes, okay, right now motor number 4 is running. Then we can remark the network. Right, remark the network. Okay, I will go to networks and then offline first. Here we can command stop motor number 1. Command stop group of motor 1. This one command stop group for motor number 2. This one motor number 3. And this one for motor number 4. Yes. And this one for reset. Command reset the sequence, right? Sequentially, yes. Okay, so that's all, and then we can download to the CPU again, and I will show the status on the PLC also when we start and stop. Yes. So we can online. Yes, wait for online. So right now the motors is running, right? Then I will show the status on the PLC. So right now the output is turned on for motor number 1, number 2, number 3 and number 4, right? So if we try to stop group and then let's see the status together. Motor number 4 was stop. Wait timer for stop motor number 3. Yeah, number 3 stop. Number 3 was stop. Then wait timer for stop motor number 2. Yeah, number 2 was stop. Yes. And wait timer for stop number 1. Okay. So right now the motor number 1 was stop also. Then we can try to start again. Okay, if I push start, wait timer for start. Okay, motor start. So we can connect the cable from the output to control the relay. Then we can connect from relay to contactor, then connect from contactor to the motor. Yes, so it's very easy to wiring. So finish, start, finish. Then I will try to stop again. Okay, stop. For timer, if we would like to slow or fast, we can adjust from start to stop, right? So we can adjust the timer to match with our process. If process fast, we can adjust fast. If process slow, we can adjust start and stop with slow. Yes. So it will stop. Okay, it will stop all. Yes, right now it stop all. So it worked perfectly for this program. And if we would like to add more for protection, for emergency stop, and for other protection, we can add more. Yes. Example, I will put the emergency here, so we can put the button here. Yes, I will show to everyone. So right now I will put emergency stop. So I need to create one more for emergency stop. So I will put the emergency stop for example M30.0. Emergency stop. Copy. Then we can try to stop all. We can try to stop all network. Yes. We can add for all network. This one should be stop also, right? Okay, this one stop already. Then when push the emergency stop, we can cut all this. So this motor cannot run, right? Okay, emergency stop. We can save and compile. And then I will download to the PLC again. Okay, then we can create the new tag for emergency stop. Emergency stop M30.0, right? 30.0. Then we can go to create the screen for emergency stop. I will put the button also stop. So I will choose the color. I will choose the red color for stop. Sorry, this one should be black. Yes. And then I will try to change the color, change the size to be 13 or 14. Yes, 13 or 14. Then I will try to go to events, go to freeze, and then I'll go to click and then choose the invert bit, emergency stop, right? And then for color animation, I will when we turn on the emergency stop, then I will change the color to be blink. Yes, blink this color. It means that emergency stop. Then we can try to simulation. Okay. So let's go to see the OB1. So when we push the emergency stop, let me pull the emergency stop. Let's see, all circuit was cut by emergency stop, so we cannot start and stop something. Yeah, it not work. We cannot do anything. Yes. So we need to put the emergency stop. Yes. Then we can start. If we push stop, it will stop also, right? Okay, I will test the emergency stop. Okay, so right now all motor was running. Then we can emergency stop. It should be stop, right? Okay, let me put put like this. It not stop right now. I will put like this. No need to cut the block, right? Then we can cut only when emergency stop. Then I will reset all output, right? Reset the output to control the motors. So reset Q 136.0. Q136.1, Q136.2, and Q136.3, Q136.1, Q136.2, Q136.3. Yes, I will reset the output here, 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 and reset here. Okay. So let's try to download. Okay, compile the program, and then download to the CPU again. And we will try to test again. Okay, right now all motor was stopped. Then we can try to test again. We start group again. Okay, motor 1 was run. Motor 2 was run. Motor 3 run. Motor 4 run. Then we try to push the emergency stop. Yes. So all motor should be stopped like this. Yes. So that's correct. Okay, so this is just example about how to create the function block and create the sequence start and stop the group for motors by using the GAA Portal version 17. Yes. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video, and I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the Pt-100 sensor or RTD sensor to PLC S7-300 by using the CPU 314C 2pn/dp. So before go to create the new program for test, I would like to explain a little bit about how to wiring directly from the PT-100 or RTD sensor to PLC terminal. Okay, so here is just example about how to wiring, and here is the PT-100 or RTD sensor. Normally there are 3 or 2 wires of PT-100 and the value is ohm if we measure by multimeter. Yes, so normally 100 ohm is 0 degrees Celsius. Yeah, and if the value of ohm is increased, the temperature will change also. Okay, so depend on the temperature. Yes, if temperature is hot, then the value of resistance will increase the ohm also. Okay, and here is the connection of PLC. I will connect to 14 terminal 14. Yeah, totally there are 20 terminal of this connection. So one cable I will connect from the PT-100 to terminal number 14, and number 1 and number 2 of PT-100 I will connect together and then connect to the terminal 15 of PLC. Okay, so there are 5 channels for PT-100, for analog input of the CPU that built in the CPU. Yes, it means that if we purchase the CPU 314C 2pn/dp, we will got 5 channels of analog input and 2 channels of analog output, and there are many digital input and output also. Yes, and I will use TIA Portal and SIMATIC Manager for create a new project and HMI to test with the real PLC. Okay, I will connect the LAN cable from my PC to the Profinet port of CPU, and then communication for download the project to the PLC. Okay, so let's go to create the new project for test together. Okay, so first let's create a new folder for PT-100. And let's open the SIMATIC Manager. I will use SIMATIC Manager for create a new project for PLC and TIA Portal for create the HMI. Yes. So first let's open the SIMATIC Manager. Okay, and then create a new folder or new project. Example sensor, and browse to find the folder that we already created on desktop. Yes, the folder name is PT-100 project, and then click OK. And we need to insert the object SIMATIC 300 station, right? So click SIMATIC 300 station, and this one example PT-100. Go to hardware, and I will insert the rack of S7. Yes, SIMATIC S7-300. So go to the rack, insert the reel, and then I will insert the CPU. Yes, so go to CPU 300 and then go to CPU 314C 2PN/DP version 3.3. So drag and drop the CPU module to the rail, and here is the IP address of the CPU. Yes, that we already connected the LAN cable to Profinet port of CPU. So click OK. We will got DI, DO, AI and AO. Yes, the same slide that I already explained. So if we check the CPU, we will got digital input 24 bits, digital output 16 bits, analog input 5 channel, analog output 2 channel, and it also counter, yes, counter function and position function also. Okay, so first let's go to configure the address of analog input and output. Go to address, so here the default address, so it will start from PIW 800 until PIW 809. Yes, and the output will start from PQW 800 until PQW 803. Okay, so let's go to input option. So the temperature of the module is degrees Celsius. We can select with the Fahrenheit and also Kelvin. Yes, so right now I will use degrees Celsius. And for the input channel number 0 until channel number 4, yeah, we have 5 channel, right? So I will select to current for 220 milliamp. Yes, if we would like to use voltage, we can use the volt 0 to 10 volt also. Yes, I will select channel number 3 with the 0 to 10 volt. And for channel number 4, it's the channel that we use connect the Pt-100 to the terminal, right? So I will select with the resistance, yeah, Pt-100 standard RTD2L, yes. And for the output, we can select 2 volt or milliamp also. Yeah, I will select channel number 1 with volt 0 to 10 volt, and channel number 2 with the current 4 to 20 milliamp. Okay, so it is very important for this configuration. If we set the wrong configuration, it will not work. Yes, so I will select with Pt-100 standard value and then save and compile the project. And then we need to download the hardware configuration to the CPU, right? So let's click download, because right now I already connected the LAN cable. So wait a moment for detecting between PLC and PC. So take time a little bit more for this detecting. After that, we will download the hardware configuration and then check the actual temperature, right? So wait a moment for detect. Okay, so right now it detects one CPU 192.168.0.1. Click OK and then click OK again to download, and it will stop the CPU when we click OK to confirm, and then restart the CPU back after download the hardware configuration. Okay, so right now the CPU is started. Then we can go to see the status of the temperature, because we already know here it will start from PIW 800, right? So PIW 802, 804, PIW 806, PIW 808, right? Totally 5 channel for input. So the Pt-100, it will be PIW 208, right? So we can go to check here, go to click block, yes, can click block and then go to PLC, go to monitor, modify variables, and then write PIW 808, and I will view as decimal, and we can online, yes. Let's see here. Right now the temperature is around 26 degrees Celsius, 26.9, yes. And I will show how to calculate with the actual temperature, yeah. So it is 268, 69, right? Swing a little bit, no problem. So if I hit the temperature, I will hit the temperature, I will hit the sensor, yes. So if I hit the sensor, let's see the value already increased to 65 degrees Celsius, yeah. So if we would like to calculation, we can go to block. I will choose later. Okay, this one should be show the actual temperature from Pt-100. Okay, so first we can convert from integer to double integer and then convert from double integer to real, right? So I will go to convert. I will convert from integer to double integer, yes. So this one PIW 808, right? I will comment the address as sensor 1, yes. And then we will convert from double integer to real, right? So double integer to real here. And this one we can create the temporary variables, yes. I will create one temporary variable, example temp var1, and the data type should be double integer, right? So I will select double integer, yes. And then this one we can use temp var1, it is double integer, and this one also. And we can convert to real, right? Okay, I will create one more temp var2, it is the real data type, yes. And I will convert to real, right? So this one we can use var temp2, yes. And then I will divide by 10.0, yes. So go to divide, go to device, right? Device, yes, this one. Go to device real, drag and drop the block. And then for this one, I will use temp_var2, yes, because it is the real data type. I will divide by 10.0. And this one is the memory that show to HMI. So I will use MD 60, yes, example, MD 60. The word, right? We can use real. Actual value to HMI. Yes. And then we can save and then download to the CPU. And we can online. Let's see right now the temperature around 28 degrees Celsius, 28.4, yes. So if I hit the sensor, let's see. Let's see the temperature is increased to 72 point something, yes. And then we can take this address to show on the HMI, yes. So let's go to TIA Portal. We can create the HMI and then show this temperature, yes. So we just convert from integer to double integer, from double integer to real, and then divide by 10.0. We will got the actual temperature that connect directly from the Pt-100 to the PLC. Okay. So we will go to create the HMI project and then show the actual value of Pt-100 on HMI. So wait a moment for open the TIA portal. Actually, we can use WinCC or other software to connect with the simulation also. So I will create new project. Pt-100 sensor. Pt-100 sensor HMI, yes. And then browse to find the folder that we already created on desktop. So I will use the folder that we already created here and click create. Okay. So 34 degrees Celsius, right? Because it decreased. Okay. And then go to project view. Yes. And then go to add new device. We will create the HMI. Yes, click HMI and then go to SIMATIC. We can choose another option that we want to simulation. I will use the TP700 Comfort version 17. Click OK. Yes. So wait a moment for insert the HMI, and then just click finish. Yes, it will create the screen automatically. Yes, follow our setting. Okay, and we can delete because we need to put the content, yes, of the project. And then we can go to connection. Yeah, first create the connection to link to the PLC S7-300, right? So PLC 1, and then choose the communication driver with the PLC S7-300 400. Yes, and then connect with the Ethernet because we use the floppy net port. Yes, so I will check my computer IP address. So IP config. Okay, my computer is 192.168.0.253. So .253, and the PLC is 192.168.0.1. Yes, it is correct. And then go to create the text. Yes, let's go to text. So first we need to show the status of the sensor, right? Okay, so MD60. So we will create the new text sensor 1. It is integer. Sorry, it is real. Yes. And we use the connection connect with the PLC. And for the address is MD60, right? So MD60. And for cycle time, I will use 100 milliseconds. Yes. And then go to the root screen. Okay, delete this one. So actually we just drag and drop from here. Go to the text default and then just drag and drop the text that we already created to the HMI. Yes. And for the format, we can go to set the format. Example, the background is black, the text is green, and the border is solid. I will choose solid. Yes, and we can adjust like this. I will choose color white. And for the option, we can property and go to general. We can choose this one with the input or output. I will choose output because it is output, right? And for the format, we can adjust example 999.99. Yes. And we can adjust the text format, center, middle. Yes. and we can adjust the font size to be 27. Okay, so we can simulation, but before simulation we can insert the label. Yeah, insert the label. So degree Celsius, right? Degree Celsius. Okay, we can put like this. And we can change the color to be yellow, and background of screen I will change to this screen. Yes, change to this color. And then we can save, and then we can go to the screen and compile the screen. And we can simulation to see the status of the temperature, right? Because right now we online with the SIMATIC manager, so we can simulation. Yes. Okay, let's see here. Right now the temperature is show around 27, the same this one. Yes, so we can go to increase the size a little bit more. Increase the size to be 32 or 36. Yes. And then we can go to insert the text. So TIA Portal version 17 connect with PLC S7-300. So for the background I will design with the color also. Yeah. Okay, this color also, and I will change this one to yellow. Actually this one we can adjust the size. Go to property and then go to set the central. For layout we can uncheck the fit to adjust. So it should be 27. Okay, let's test this one. It's okay or not. So save, and then simulation. We will use the simulation. Cancel. Yes, we use the simulation. Okay, so big, right? So we can adjust the size, decrease the size a little bit more. I will increase to be 23. Yes. And then let's simulation again. Okay, good. Enough for space. So we can adjust this one like this. Yes. And For temperature, we can put like this. So actual temperature sensor, sample sensor 1. Sensor 1 so around, yes, 27 degrees Celsius, right? Okay, let's simulation. And then I will hit the sensor again. Okay, right now around 27 degrees Celsius. So I will minimize this one. And then we can hit the temperature, yes. I will zoom in, yes, zoom out a little bit, yes, and put the screen here. Okay, so let me hit the PT-100. Okay, I hit the PT-100. Let's see, the temperature is increased very fast. Yes, 80, 89, 90 degrees Celsius. Yes, so it's linear with the formula. It will decrease again. I will hit to be 100 degrees Celsius. Okay, 100 degrees Celsius, right? I will adjust this one a little bit more because the space is not enough, right? So we can adjust this one. Okay, like this. And then we can simulation again. Yes. Okay, good. So the temperature is the same as the actual because I hit the sensor. Yes. So this is just an example about how to wiring the PT-100 or RTD directly to PLC S7-300 by using the CPU 314C2PN/DP. Yes, and this is just the general formula for calculation from the raw value to the actual temperature. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the PT-100 sensors or RTD sensor to the PLC S7-300 CPU 314C to PN/DP. In the previous video, we already learned about how to connect the PT-100 sensor directly to PLC, and we already tested with the real PLC. And for this section, I will add one more transmitter. This is a transmitter for convert from signal 2Y to 4Y. Because the PLC we can select only 4Y. Yes. And I will connect the PT-100 with the RS transmitter. It is convert from ohm to milliamp. Yes. And then I will connect to the PLC. Okay. And in this section, I will use TIA Portal version 17 and SIMATIC Manager version 5.6 to create a new project. For SIMATIC Manager version 5.6, I will use for create the PLC hardware and software and then download to the PLC. And for TIA Portal, I will create the HMI or touch panel project, and then we will simulate with the PLC also. Okay. So before go to create the new project, both PLC and HMI, I would like to explain detail about how to wiring the converter, transmitter, and PT-100 and temperature transmitter. Yes. So let's go to detail about the second temperature sensor. So here is the detail about how to wiring to PLC by using the temperature transmitter model RS363. Yes. And here is the PT-100 or RTD. It is the ohm. Yes. And I will connect the two cable for this terminal of temperature transmitter, and one more cable I will connect to here. Yes. And here is the transmitter for convert from 2Y to 4Y signal. So I will use terminal number 1. Yes. When we supply the voltage 24 voltage, yes, I have power supply input 220 volt AC and output 24 voltage. So I connect the terminal number 9. Let's see here. The terminal number 9 is the supply to transmitter to converter. Yes. And terminal number 10 is minus. Yes. So I will supply 24 volt DC to here, terminal number 9 and number 10. After that, I will use the terminal number 2 here, and number 3. Number 2 is minus, number 3 is plus. And then I will connect to supply to the temperature transmitter. Yes, RS transmitter. So when we supply number 10 and number 9, it will have output to number 2 and number 3 is 24 volt DC also. So I will connect to RS transmitter. After that, it will generate the signal for 220 milliamp from terminal number 5 and number 6 from this transmitter. Yes. So when I hit the temperature sensor or RTD, the milliamp will adjust to terminal number 2 and number 3, and then number 5 and number 6 will adjust, increase also. Okay, and I will connect to the PLC terminal number 3 and number 4 here. Yes, so we can measure the temperature also. Okay, so I hope everyone will understand about my wiring. Yes, because it's very detailed. Yes, with the terminal here. Okay, so let's go to create the PLC project and then download to the PLC, and let's see the status together. Yes, and for the PT-100 number 1, I will keep the same as the previous video. Yeah, connect directly to the terminal of PLC because it has this CPU has option connect directly PT-100 one sensor to terminal number 14 and number 15. Yes. Okay, so let's go to create together. Okay, so I will use these two software, SIMATIC Manager and TIA Portal version 17 that are already installed in my PC. Yes. So first I will create a new folder, temperature sensors. Okay, temperature sensor. And first let's go to open SIMATIC Manager. Yes, open SIMATIC Manager version 5.6. Yes. Okay, and let's go to create a new project. Okay, I will put the project name temperature sensors and browse to find the folder that we already created on desktop. Yes, so let's go to temperature sensors and click OK, and right click on the project and then insert the object, and I will insert the new object for SIMATIC 300 station. Yeah, and this one example temperature sensors, and go to hardware configuration. Yes, so I will insert the rack of PLC S7-300. Yeah, so drag and drop the rack to the project. Yes, we will got one reel here, and I also insert the CPU. So our CPU is 314C 2P/DP. So drag and drop to the reel. Okay, and this is the IP address of the Profinet port of the CPU. So click OK to confirm. So here is the Profinet port that we already learned in the previous video. So right now I connected the LAN cable from my PC to the Profinet port. Yes, and the IP address is 192.168.0.1. Yes, and we need to configure the input, right? Analog input here, because it has many types that we can select. So the address will start from 800 until 809, totally 5 channels, right? And for analog output, it will start from 800 to 803, it's 2 channels. So let's go to configure the input. Okay, temperature unit is degree Celsius. If everyone would like to select with Fahrenheit degree or Kelvin degree, we can select also. Okay, so I will select to degree Celsius, and for the input type I will select to current, yeah, for 220 milliamp, because our transmitter is for 220 milliamp, yeah, here. Okay, so input number 0 I will select to for 220 milliamp. Input number 1, number 2 and number 3 I will keep the same, yes. And input number 5, yes, number 4 I will select with the RTD2L, yes, it is the standard Pt-100 standard, yes, here Pt-100 standard, yes. Okay, so we just config two channel that we will use for channel number 0 and channel number 4. Okay, so let's click OK and then save and compile the project, and then we will download to the PLC, right? Download the hardware to PLC. So click here to download, but before download, make sure our computer is already put the manual, yes. Okay, 192.168.0. something, yeah, but not .1. Okay, so let's click download. Okay, I will download the hardware configuration and I will stop the CPU. After that, we can click yes to start the CPU. Okay, so for the hardware configuration, we already configure and download to the PLC. So we will continue to create the logic or block to see the status of the temperature, right? So let's go. Okay, so here is the OB1. Actually, we can check the status of the temperature, yeah, because we already connected the sensor to the PLC, right? So we can go to check here. Go to PLC and then go to monitor, modify variables. And for the address, it start from PIW 800, right? So PIW 800 for sensor number 1. Sorry, sensor number 2. And one more PIW 808, right? The last one. And then we can online to check here. So the sensor number 1 around 25.9 degrees Celsius. And this one we need to use the scale to convert from the raw data to the temperature, right? Okay. So we can go to the blocks. Okay, double click OB1 and I will use ladder. Okay, so example sensor 1 status. Sensor 1 status. So for sensor 1, the signal is connect directly from the sensor, right? So we just divide by 10. We will got the actual temperature. Yes. So I will convert from integer to double integer, right? So integer to double integer. Okay, integer to double integer. And integer, here we can see the status. So PIW 800H, PIW 800H, it is the sensor number 1, right? Okay, I will zoom. It is the sensor number 1. So sensor 1. Okay. And I will convert from double integer to real, right? Because we need to divide by 10.0. So I will create the temporary variables. Yes. Example temp value 1. And the data type is double integer, right? So double integer. And then here we can use temp value 1. Yes. And then I will convert from double integer to real, right? So go here, insert the empty box, and then di to real. Yes, di to real here. And here I will use temp value 1 and insert one more, create one more for temp value 2. It is the real, right? So data type is real. And here we can use temp value 2. Yes. And then I will divide this one with the value 10.0, right? So go to divide real here. Sorry, divide real, div real. Then I will divide this one. Yeah, we can also copy and paste. Yes. And then divide by 10.0. And we will show the status of this one, right? So I will use the memory MD10. Yeah, example MD10. This one I will remark as show at HMI. Yes. And then we can save and then download the block to the PLC. And then we will see the actual temperature, right? 25.9. Yes. Okay, so this is a sensor number 1 status. If we would like to show the sensor number 2 status, we can insert the network. Yes. Insert the new network. Yes, so this one should be sensor number 2 status. So how to do that? We need to convert from the raw value here by using the scale, right? The library has scale. Yes, so let's go to library and then go to standard library, go to TI S7 converting blocks, and then we will use FC105 scale convert. Yes, just drag and drop to the network. We will see the block. Yes, the new block is scaling values. Yes, so here is the input. Here is the input. So input is PIW 800, right? Because I already connected to the terminal number 3 and number 4. Here is the channel number 1. Yes, so PIW 800. So this one should be sensor 2, right? Sensor 2 input. Sorry, the data type is integer. Okay, and high scale is the high scale and low scale compare with the temperature transmitter, right? Compare with this one. Yes, for this one I use 0 to 100 degrees Celsius. It is the range that already wrote on the nameplate. Yes, so very important, we must see here. Yes, so I use 100.0. It means that 100 degrees Celsius. And low scale I will set as 0 to the low scale limit. And for this point it is the bipolar or polar option, so I can use M 2.0. Yes, and here is the output. Yes, so I can use MW 15. Yes, and here is the raw value, sorry, actual value that will show the actual temperature, right? So I will use MD, this one MD 10, right? I will use MD 20. Yes, so show at HMI for sensor 1, right? This one for sensor 1. Sensor 1 show on HMI, and then I will copy for sensor 2. Sorry, it is the real, right? Okay, the same as this one. And then we can save and then download the block. Yes, we need to download the block because we just insert the new block to the project. Yes, so I will save and then I will close this one, and we need to select all this block and then download to the CPU again. Okay, and then start the CPU. Yes, CPU is started, and then we can go to OB1 again, open, and go online. We will see the status of the temperature, right? For the temperature number 1, or this one should be 0, right? Normally 0, yes. Temperature number 1 is show around 24 degrees Celsius. Temperature number 2 around 25 degrees Celsius. Yes. So that's correct. So if I try to hit the sensor, let's see the status. I will hit the sensor. Right now I hit the sensor number 1. Yes. So sensor number 1 is increased. Yes. Example, I will hit the sensor number 2. Sensor number 2. Let's see the temperature is increased also. Okay. And then we can go to create the project on the TIA portal to show on the HMI. Yes. So let's go. Open the TIA portal version 17. So wait a moment for create the, open the software. Yes. It depends on the computer performance. If the computer performance is high, so we can go fast. Okay. Okay, so let's create the new project. Example, temperature sensor HMI. Yes. And then I will browse to the folder that we already created here. Click create to create the project. Yes. So it takes time a little bit more for create the project of HMI. Yes. Actually, we can use the TIA portal to download to PLC S7-300 also. But in this section, I would like to show and share about how to separate the software. So we can use both SIMATIC Manager with the TIA portal. Yes. Okay. So let's go to project view. And then go to add the new device, double click. Yes. And then go to HMI tab and then go to use the TP700 comfort, the same as the previous video. So it will take time a little bit more. Okay, so let's go to finish, click finish. Okay, and I will delete this one, this one, this one. And so first let's go to create the connection. Yes, double click on the connection. Add new connection. Example, temperature connection. Yes, temperature connection. And then choose the communication driver. So I will choose SIMATIC S7-300 400 and choose the Ethernet protocol. Yes, and here is the IP address of my computer, so 253, and address of the PLC is correct, 192.168.0.1. Yes, and then go to create the text. Yeah, if we would like to show, we need to create the text. And then we need to remember the text here that we would like to show. So MD10 for sensor 1. Yes. So I will create the new text, sensor 1. And the data type is real, right? The data type is real. And I will use the external connection here. Temperature. And for the address, I will use MD10, right? Because we need to show the temperature sensor status number 1. Yes, so MD10. And for the cycle time, I will adjust to 100 millisecond. And sensor 2, it is the real also. And I will change to MD20. Yes, this one, MD20. So MD20, 100 millisecond also. Yes. So that's all for create the text. And let's go to root screen. Yes, you can compile the text. So software compile will start. Okay. And then we need to show the actual temperature here, right? So I will change the screen resolution, sorry, screen color to be this color, the same as the previous video. I will use rectangle. And change the color to be this color also. Yes, and then I will create the text. connect temperature or connect RTD Pt-100 to PLC S7-300. So we can change the text to be yellow, yes, and go to layout and check the fit object to contents, so we can adjust. Normally 23, right? So align to be center. $25 also okay, right? So let's test with 25 for size. We can compile again and then simulation. Okay, we need to adjust a little bit more. Let's simulation again. Okay, good. Then we can go to the text and then drag and drop the text to the HMI, yes, for sensor 1, and this one for sensor 2. Yes, and then we can put the text as sensor 1. Sensor 1. And sensor 2, right? Yes. And then we can simulation, yes, to see the status of the temperature, yes. Okay, so temperature sensor number 1 around 25.9 and number 2 around 24.1, yes. So I will adjust to be bigger than this one. So let's go to property and then go to general, and this one should be output, right? And go to apparent, and I will adjust the color of background to be black, and text color I will adjust to be green, yes. And I will adjust zoom bigger than this one and change the format, yes, we can change the format to be example 999.99, yes. And we can change the text size alignment also, yes. And for the apparent, we can also adjust the color, solid, example color white, yes, and we can adjust the width also, yes, like this. This one we can change the color, $29, yes. And the unit is degree Celsius, right? So degree Celsius, the unit is degree Celsius, so we can put like this, and then we can group. Yes. Okay, group, and then we can adjust together. And for the sensor number 2, we can copy, yes, copy all. So right click, copy, right click, paste. And then we just change this one to be sensor 2. This one we need to use the text. Change the text with the sensor 2, right? Okay, good. And I will adjust this one to be 27. Yes. So that's all. And then we can simulation. Okay, good. So I will adjust or hit the sensor again. Yes. So let's see the status when I try to hit the sensor. Yes. Okay. I will put like this and try to hit the sensor. Yes. Let me hit the sensor. First, I will hit the sensor number 1. Let's see the temperature will go up. 65 to 70 degrees Celsius. And I will try to hit the sensor number 2. Go up also, yes. 50 degrees Celsius, yes. So the simulation with the PLC is working properly, yes. So we will conclude this tutorial. This is just an example about how to connect the Pt-100 or RTD from temperature transmitter to the PLC, and from the sensor directly to PLC. So there are two types that we can use. I hope everyone can apply to our project. If we have project would like to show example the temperature of bearing of motors, temperature of tank or something, so we can apply like I already show and share. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today we will continue to learn about how to wiring Pt-100 or RTD sensors to PLC S7-200 Smart CPU SR30 with the analog module EM-AM03. So if we would like to talk about EM-AM03, there are two inputs of analog and one output of analog also. Okay, so totally 3 analog, 2 for analog input and 1 channel for analog output. Okay, and here is the address AIW16 for analog input channel number 1, and AIW18 is analog input for channel number 2. Okay, and I will use the sensor Pt-100 or RTD connect to the RS transmitter, temperature transmitter that convert from ohm to milliamp. Okay, so in this section I will use two sensors connect to the temperature transmitter RS3630230H and then connect to the analog of PLC. Okay, so here is the converter, convert from 2Y transmitter to 4Y, yes, and then connect to the PLC. Because PLC is 4Y and transmitter is 2Y, so we need to convert for from 2Y signal to 4Y. Okay, and I will use TIA Portal version 17 and Step 7 MicroWin Smart version 2.5 to create the scale and create the logic to show the status of the sensor. Okay, so before go to create the project of TIA Portal and SIMATIC Step 7 MicroWin Smart, I would like to detail about how to wiring. Yes, so for sensor number 1 we have like this. We have sensor, right? So sensor, the two wire is connect together, and then we can connect to like this, connect to this terminal of temperature transmitter, and one more core we can connect to this terminal, and we have power supply 220 AC convert to 24 volt DC, and then connect to terminal number 9. Number 9 is plus and number 10 is minus, and we have terminal number 1, number 2 and number 3 So I will use number 2 and number 3. Number 2 is minus, number 3 is plus. So we can connect to supply the temperature transmitter. And then we will connect the terminal number 5 from the converter. Number 5 is plus, number 6 is minus to the PLC S7-300 smart, yes, analog module here, connect here. So the signal from the converter is 4 to 20 milliamp. Then we need to convert the scale, right? We need to create the scale. I will detail when we create the program. And for the sensor number 2, there is the same way that we can connect, but we just change this one, connect to analog input channel number 2. So AIW18, yes. So the way of connection is the same, so we can follow this step. It's very easy to wiring, yes. Okay, so let's go to create the scale, yes. Okay, so right now I will use two software together. The first one is Step 7 MicroWin Smart. The second one is TIA Portal for show the signal of temperature sensor. Okay, degree Celsius. So first let's open the Step 7 MicroWin Smart. And then we need to set up the hardware configuration, right? Because we use the analog module EMAM03, yes, so we need to set up the hardware configuration. Okay, so first let's go to double click CPU SR30. If everyone use other CPU, example ST60 or something, so we can choose the same as our hardware. It means that the same as the real PLC that we use. So for me, I use SR30, so I select SR30 and then go to start up. Here is very important. If we choose like this, it means that when we turn off and turn on the power again, the CPU will not run, right? So I will select to run. And then we can insert SB for slot number 1. I will choose battery. And EM0, I will use EMAM03 here. It is 2 AI and 1 AO. It means that 2 channels of analog input and 1 channel for analog output. Okay. So the address will start from AIW16 for analog input, and analog output it will start from AQW16. Okay. So 2 channel it will count AIW16 and AIW18. Okay. So the same as I put here. The channel number 1 is AIW16, sorry, and the channel number 2 is AIW18 used for sensor number 2. Okay. Then here we can configure the mode. So the input we have 2 channels, right? Channel number 0 and channel number 1. So I will use current, yes, because right now we use current. And here has only 0 to 20 milliamp, yes. But the temperature transmitter and converter is 4 to 20 milliamp, yes. So we need to create the scale. And for channel number 1, I will use 0 to 20 milliamp or so. Yes. And if everyone would like to use the analog output, we can use also. Yes. Example, select with current, select with volt. Yeah, I will select volt. Yes. Sorry, current also. So this is very important. If we select wrong selection, we cannot measure the temperature, right? Okay, so it's very important for hardware configuration. And then click OK. Yes, and we can save the project. I will create a new folder, Pt-100 with PLC S7-300 Smart, right? So example project. Yes, and we need to convert, right? We need to convert the scaling. Yes, so before convert the scaling, I will show the status of the temperature right now. Yes, I will show only raw data, so it is integer, right? So I will insert the integer convert to double integer. So the channel number 1 is AIW16. Example VD20, and we need to put the always on, right? And for channel number 2, so we just test the point or test the analog input first before create the scaling. So this one example AIW18, yeah, it is channel number 2, right? VD30, yeah, example, and then we can save and then compile the project. There is no error, right? So we can download. Before download, we can scan the IP address of the PLC, right? Because we use LAN cable connect from our PC to the Profinet port of the PLC. Yeah, so we can scan. Okay, right now we cannot scan, right? So we need to put the IP address of our computer. Yes, so right now I use Visual Machine. So I use select to this mode, and then I will scan again. Okay, so right now it detects one CPU that has IP address 192.168.0.2, and then we can put our computer IP address to be the same as the rank of the PLC. So I will put 192.168.0.253, subnet mask 255, 255 and 255.0, right? And then we can click OK to download. Yes, and then we can online. So right now the analog input has raw data, yes, raw data around 11,000, yes, the same as the condition, because right now I already connected the sensor to the converter and connect from the converter to the analog, yes. So it shows raw data like this. Then we can convert the rank from this raw data to the actual temperature, right? So I have one formula, yeah, here. So output equal input minus low scale input. It means that input, it means that this one, yes, minus low scale in, and then multiply by high scale out minus low scale out, and all this I will divide by high scale in. It means that high scale input minus low scale input, and all this one I will add by low scale output, right? So it is the same as here, yeah. I will press F1, yeah, and then explain here. So we can search scale. There are scale integer to real, real to integer, real to real, right? So first we need to convert from integer to real, right? So double click here. We will find the formula here, yes, the same as my formula. So the output is out, variable type is out, and the data type is real. So the input is in and integer, yes. So input is integer here. Here is integer. Then OSH, it means that real, yes. Input 2. And definition here, scale output value, analog input value, yes. And for OSH, it means that real data type, high limit of scale of the scale output value. And OSL, it means that low limit of scale for scale output value, yes. So we can copy this formula to use, yeah, because if we install the software step 7 microbit smart, we will got like this. So we just press the F1 on keyboard, yes, and then search scale, and then double click scale integer to real. We will got this formula, okay. So we can use this formula, okay. So I will copy this formula to our project. Okay, so this one I will delete first because we already test the analog signal. And then pass the formula here, yes. So we need to create the variable, right? Parameter input and output, the same as the head, right? Here we have totally 1, 2, 3, 4, 5 input and 1 output, right? And the data type we have real and integer, right? Okay. So we can follow this formula. Actually, we can copy to use, yes. So let's go to create the variable. So let's go to SBR0. Yes, and then we will create the input and output, right, for parameters. Yes, let's see the help for detail here. Yes, the purpose of this subroutine, yes, to scale integer number from input range to real in the output range, right? So first here it already detailed. Yes, the software already detailed for us. So we need to insert the parameter. Yes, so the first one I will insert the parameter input. So we have input, right? So input, it is the real, right? Input integer, the data type is integer, so we can copy command. Yes, analog input value, and we have OS8, right? So OS8, it is the real, right? For data type it is the real, so we choose real. And for description we can copy here. Maybe I will put like this. And I will put our project like this, easy to copy. Okay, paste. And next OSL, right? It is the real also for data type, so we can choose real. And the description is low limit of scale for the scale output value, so we can copy and paste here. Next IS8, right? So IS8, it is the integer. And then we can copy the description and then paste here. And next is ISL, so ISL, it is integer also. Then we can copy the command, yes, and then paste here. And we have output, right? So output, so we put here output, and the data type is real. Description is scale output value. Yes, and then we can follow this formula. So the first one, we can use the all way on, right? So double click and then all way on. And we can use sub, right? Sub real. So I will zoom a little bit. So we have sub real. So sub between OSH, so we can type OSH and OSL, right? And we got OSH. And then we can sub integer. So sub integer. Yes. And we can connect. So sub input. So input ISL. Yes, this one. And then this one input. And the next we can convert from integer to double integer. Yes. So integer converter, right? Convert from integer to double integer. Yes. And then convert from input to create the temporary. Yes. I will create the temporary here. It is the temp D, right? Temp underscore D. It is the double integer. Yes. So here I can use temp D. And the next step we can follow by this formula. Double integer to real, right? So convert from double integer to real. Yes, drag and drop. And then convert from temp D. So temp D convert to temp R, right? So I will insert one more temp. Temp R. It is the real, right? Data type should be real. So temp R. And then we must multiply by OSH, right? So multiply real. So go to plotting mode, multiply real, and then multiply by temp air with the OSH, right? OSH. Yes. So we can check sub real, yes, subtract integer, convert from integer to double integer, convert from double integer to real, and then multiply by high scale out, right? And then we can continue to network 2. So I will insert all way on, and then sub integer, right? So sub integer, go to mathematics, sub integer, sub the ISH by ISL, ISL, and then equal ISH, and then convert from integer to double integer, right? So convert from integer to double integer, convert ISH, convert to 10D, and then divide real. So double integer to real, yes, double integer to real, and convert from 10D to 10R, and then divide real, right? So go to divide real, so divide by OSH with the temp R, and then OSH, and next add real, right? So add real, so add between OSL and OSH equal OSH, and the last one move real, right? The last step is move real, so go to move and then move real, so move OSH to output. Okay, so that's all for create the scale, yes. And if we would like to use this scale, we can go to the main program and then insert the all way on, and we can call the block to use. This one should be create on int o, right? So I will copy this network. I will copy this parameter. I will insert the new subroutine, and then rename to be actually we can call this one to use. Yes, no need to create the new. So we can call this one to use. So we will got like this. So first we need to put the input, right? So AIW16, yes. And we have high scale output, right? High scale output. So let's see here. I have high scale input, low scale input, high scale output, and low scale output, right? So high scale output is 100 degrees Celsius. So I will put 100.0 and low scale out 0.0, and input high scale I will put the maximum of the analog input range, yes. So 27648, and then low it will around 5550 because I already test with the standard source 5550, and then for output I will use, it is real, right? I will use MD40 or MD10, yes. We can compile. So we have some error, right? Total error 28. The row 1. Oh, this one should be deleted, right? No need to use. Okay, we try to compile the program again. So there is no error, right? Then we can download to the PLC, and then we can start the PLC and online, yes. So right now the temperature around 27 degrees Celsius, yes. So I will hit the temperature sensor, and then let's see the result, yes. I will hit the sensor number 1. Let's see, the temperature is increased to 65 degrees Celsius. Yes. So that's correct. And then if we want to use the sensor number 2, yes, we can use also. So we try to copy here, and then we use the always on, and just change this one to be AIW18, right? Okay, no error occur, and then change this one to be MD20, yes, and try to download. Okay, let's see the value is changed between temperature sensor number 1 and number 2. So I will hit both sensor. Let's see the temperature is go increase together because I hit both sensor. Yes. So the formula that we created is correct. Yes. We can also simulation on Excel. Yes. Because the formula is the same. Let's see here 16014, so around 47, 45. Yes, here. So the formula is correct. Yes. And then we need to show the signal of temperature on the HMI, right? So we can go to TIA portal. So wait a moment for open the TIA portal software and then go to create the new project. So I will put the project name PLC S7-300 Smart with sensor. Yes. And then go to the folder. I will put on the folder that we already created here. Yes. And then click create. So wait a moment for create the project of TIA portal. And then go to project view. And we need to create the new device, right? So double click on new device. And then go to add the HMI. Yes. Because we need to show the HMI. Sorry, so the status, the actual temperature on HMI, right? So I will use this model. Yes. So take time a little bit more to create the device. Okay, just click finish. Okay, I will delete all this one and then we will put the label, right? Connect temperature sensor to PLC Smart S7-300 Smart. I will put the rectangle like this and then change the background of skin to be this color and this color also. and I will change this one to be 0. Yes, and for the layout I will uncheck the fit object, yes, to adjust. So first let's go to create the connection. Yes, I will insert the new connection, example PLC Smart, and the driver communication is S7-200, right? And then I will use the Ethernet because we connect using the LAN cable from our PC to the Profinet port of PLC, right? So 192.168.253, it is the address of my PC, and the PLC is 192.168.0.2 here. Yes, so I will change from 1 to 2 and go to create the text, right? So let's go to HMI text and create the text, and the text is MD10 and MD20. Yes, so MD10 sensor 1, it is the real, right? And I will use the connection with the PLC and change the address to be VD10, right? Sorry, MD10. It is the sensor 1, right? 100 millisecond. And for sensor number 2, I will use real also, and MD20. Yes, it is the address of sensor number 2. Yes, MD20. And then we can go to the screen and we can drag and drop the text. Sensor 1, sensor 2. Yes, and then save, and we can compile the screen. There is no error, right? Good. And then I will put sensor 1 here. And sensor 2 here. Yes, and the data type is degree Celsius, right? So degree Celsius, okay, and then we can group. So the data type is degree Celsius. And then we can modify the option to be 999.99, and it is the output only, right? So output. And for this one also, go to property and change to be 999.99 and change to be output only. Yes. And then we can adjust for the alignment to be text format. It should be central and middle. Yes. Okay. And then we can simulation, but before simulation, let's go to cross check the control panel. Go to set PC interface 32 bits and make sure we select the S7 online here. Yes. Otherwise the simulation is not work. Yes. And choose the network that we already connected, right? And then we can go to simulation. Okay, we got the actual temperature here. So the screen, I will adjust the screen a little bit. This one should be center, right? Okay, and then we can save and then simulation again. Yes, because I just adjust the size a little bit. Okay. So let's see here. Sensor 1 around 27 degrees Celsius and sensor 2 around 28 degrees Celsius. So I will hit the sensor again and let's see the result. I will hit together. Let's see the temperature will go up very fast. I hit until 100 degrees Celsius. Yes, 109. Yes. So it over limit, right? It will go down. Yes. So this is just a sample about how to wiring the PT-100 or RTD connect to analog module of PLC S7-200 Smart model EMAM03. Yes, and how to create the scaling to convert from the raw data to the actual temperature. Yes. So actually we can follow the hell if we would like to create anything. We can follow the hell. Just press F1 and then see the instruction. So we can do it. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to wiring the PLC S7-300 CPU SR20 with the expansion module EMDR08. Okay, so before we can test with the program, basically we must know how to wiring the connection of terminal of the PLC. I mean that connect from input to push button or output to the relay control. Yes, so we must understand about how to wiring. The first time we need to learn about how to wiring first before we create the program. Then I will explain about how to wiring this module with the CPU. Yes, so if we use the EMDR08, we have H10 more for digital output. It means that DR08 digital output 8 channel or 8 bits. And for the CPU, we have also 8 bits for digital output. Then we add 8 bit more, so totally 16 bits for digital output. And for the digital input, we have 11. Yes, we have 12. Yes, from I0.0 to I1.3. Yes, and for the address, it will start from Q0.1 until Q0.7, 8 bits. And for this one, it will start from Q8.0 until Q8.7, 8 bit also. Okay, I will detail when we create the hardware configuration for this CPU on the step 7 microwin smart, and we will create the sample HMI on the TIA Portal version 17 to test and simulation with this PLC. Okay, so I will connect the real PLC to the PC via Profinet port of the PLC to the PC, and then I will simulation from the PC by using the TIA Portal version 17 for the HMI. Okay, then I will detail more about how to wiring this terminal. Yes, so let's go. Okay, right now this just example. I have push button start and stop. Yes, that start button and stop button I will connect to the input I0.0 for start and I0.1 for stop. And if we supply 220 AC to the PLC, we will got 24 voltage from here. Yes, then we can connect to supply. Yes, first we need to supply the expansion module, yeah, DR08. So I will connect L plus to L plus of the EM module, and then M to M of EM DR08 module. Okay, and for the digital output, we can connect directly from the 220 volt to directly to the relay. Yes, so this relay is 220 for magnetics. Yes, then this one I also connect with the 220 volt AC. Yes, then this one will start from Q0.0 and this one will start from Q8.0. Okay, so input is 24 voltage, and for the output we can use both 24 and 220 AC. Okay, so it is the dry contact for this one and this one. Then we can select both, or we can connect both 24 volt DC or 220 AC. Okay, so if we would like to connect with other relay to control the motor or electrical devices, we can use 8 bits more. Yes, so we can jumping between this one and this one. Then we can use this contact to control the some electrical devices that we want. Okay, so this is just overview about how to wiring the PLC SIMATIC S7-200 Smart CPU SR20 with the expansion module EMDR08. Okay, then we can go to create the sample program or sample project test with the HMI for simulation. Okay, so let's go. Okay, so first we need to open the step 7 microwin smart and TIA Portal version 17. So I will open the SIMATIC step 7 smart version. Yes, and first we need to create the hardware configuration. Yes, so let's go to hardware configuration, double click, and then choose the CPU type that match with our hardware. So right now I will use SR20. Yes, CPU SR20, and then I will add the battery. Yes, and then I will add the DR expansion DR08 here. It means that 8DO or 8DQ relays. So let's click, and then the address will generate automatically. Let's see, the input start from I0.0 and output of the CPU, it will start from Q0.0. Okay, and for the expansion module, it will start from Q8.0 until Q8.7, right? So totally 8 bits, and this one 8 bits also. Then we can use for 16 bits for this project. Okay, and then we can go to the CPU setting and then go to startup. It's very important here. So for the startup mode, we can select 3 options that we can select. The first one is stop, the second one is run, and the third one is last. And I would like to explain the same as the previous lesson. For the stop mode, if we select like this, when we turn off and turn on the power back, the PLC will not run. Okay, and we choose the run mode. When we turn off and turn on the power again, the CPU will start automatically. Okay, and for the last, it means that when we select last like this, it means that it will remember the last state of the CPU before we turn off the power, and then after we turn on the power again, it will remember the last state of the CPU. So when the last state of the CPU is run, it will run. When the last state of the CPU was stopped, it will stop. Okay, so I recommend to use run, because at the local side we no need to restart the CPU. Example, when the electricity was cut, then we can turn on again, the CPU will running. Okay, so good. I will select run, and then we can create the sample program for test the digital output or expansion that we already created here. Yes, so basically we can write m0.0, or we can write i0.0. it is the stop button, right? Sorry, start button here. And then we can choose the stop button i0.1, and then we can choose the output. So q0.0, it is the CPU output right here. This relay will turn on, and then I will hold the signal by q0.0. Yes. So when we write a program like this, we can use only push button start and stop. Okay. But if we would like to start and stop from the HMI, we can also add more for start and stop. Okay. So I will insert the column and then insert the new button. So example m0.0, it is the stop, or m0.1, it is the stop. So stop from HMI. Yes, stop from HMI. And then if we would like to start from HMI, okay, I will insert column. NO, start from HMI, right? So m0.0. Yes. So we can start from the HMI, and then this signal will hold, right? This signal will hold. So in this case, I will parallel. So I will insert the row and then pay this one. Yes, like this. And then we can save the project. Yes, I will insert the new folder for this project. So S7-200 Smart DR0H EM DR0H. Yes, so DR0H Smart, and then we can download to the PLC, right? But before download, we can go to communication to check the communication, and then please find the CPU. It will detect the CPU, because right now I already connected the LAN cable from my PC to the Profinet port of PLC. So right now it detects one CPU that has IP address 192.168.0.20, and then please OK, and then we can download. So push download to download the program to the CPU, and then we can online to check Yes. So this one, it is the fault signal that from the last video, yes, that we already learned, right? So I will unforce all. Okay, and then I will stop. I will stop the relay first. Okay, and then we can go to create the HMI for test the case. Yeah. So let's go to TAA portal. Then create the new project. I will put EMDR08 Smart project, and then browse to find the folder that we already created on desktop. So I will choose this one, yes, and then click create to create the project of HMI. And then go to project view to create the new HMI. Yes. Go to add new device, double click. And then go to the HMI item and go to select the HMI that we want to use. Right now we use the TP700 comfort HMI. Yes. Then we can click finish. Okay, I will delete this one first. Okay, delete. Okay, so first we need to create the connection. Yes. I will add the new connection, example PLC Smart 200, and then I will choose S7-200 here. We have many drivers that we can use to connect with the PLC or OPC-UA or Modbus RTU, Modbus TCP/IP. Yes, so many drivers that we can use. Right now I will use S7-200 Smart and then choose the Ethernet, and I will check my IP address. So IP config, so 192.168.0.253, and the PLC address is 192.168.0.20. Yes. Then we can save the project, and then we can go to create the tag, right? So double click, show all tag, and then create the new tag, right? The first one is M0.0 for start M1. So the data type is Boolean, and then I will use the PLC, right? Okay, and the address will start from M0.0, and I will change this one to 100 millisecond. And then we need to create the push button stop, right? This one. So this one M0.1, right? M0.1. We can rename, yes. This one should be start from HMI. Okay, M0.1 stop from HMI. So stop M1, stop from HMI, right? Address is M0.1. Then I will change to 100 millisecond. And we need to create the motor status, right? So I will use Q0.0 motor 1 status. I will change to Q0.0 100 millisecond. Okay, then we can go to save and then compile the HMI. Should be no error, right? Because we not yet configure the any option. Yes, so I will change the background to be the same as the previous lesson. I will use this color. Yes, I like this color. So we can use another color that we want. So the first I will create or insert the motor. Yeah, we use this motor. And I will use the button. Stop M1. Then we can copy and paste. Start M1. Okay. For the faceplate, I already explained and show and share in the previous video. So in this lesson, we no need to create the faceplate again. Yes. We just put the normal condition for start and stop the motor. Okay. Then I will insert the rectangle and then choose with the send to back. Yes, send to back. Okay, I will adjust this one a little bit. Okay, like this. And I will put the rectangle one more. Okay, for the stator of motors. Then I will adjust to be center like this. Okay, I will change the background to be this color. Yeah, we can use another color that we want. Okay, then I will change this color of button to start. Okay, and then change the color button stop to be red color. Yes. And for the text button, I will use black. This one also, I will use black. Yes. And for the chamfer, yes, we can also adjust here. Zero, it means that we no need to put the cover. Yes. And then this one, I will change color to be red. The normal status, it means that motor stop. Okay, I will change the background to be this color. Yes, and then I will put the title with motor 1. And check the fit, and then we can adjust. And then I will alignment to be center and adjust the size. Yes, for motor 1. I will simulation the screen a little bit to check to confirm the screen that we created is okay. Okay, good. I will adjust this one a little bit more. Yes, like this. Yes. After that, we can show the status of the motor. Yes. So we insert the text, copy the text, and then paste. So when motor running, I will put running. Running status, and then I will use the fill to this color. Property, go to apparent, and then solid. Yes. We can show the running status when motor is run, right? Okay, like this. And then we need to configure the push button start and stop, right? So for button start, we can go to events, go to click, go to freeze, and set bit while key freeze, right? And then go to take default. I will choose drag and drop the start M1 to the events function. And for the stop also we can do freeze, set bit while key freeze, and then choose the stop M1. Yes. And for the condition, we can right click and then go to animation, go to display, add new animation, choose the apparent, and then choose the motor 1 status, and add the new. When the condition 1, it means that turn on, it will show green. Yes. And for this one, we can also choose the new animation and choose so we need to visible this one. Yes, we pop up when the motor is running. Yes, so we can go to drag and drop the motor status here, and then choose rank from 0 to 0, and then choose invisible. Okay. Then we can save and we can simulation for test. I will compile the project first. Okay, there is no error occur. Then we can simulation. Yes, and then we can go to test together with the SIMATIC Step 7 Smart software. So when I push start, let's see, the relay is turned on, then the signal motor running is pop up. Okay, when I push stop, it will stop. Start again, it will start again, and I will show the relay status when I push start and stop. Okay, so relay is running right now. So if I push stop, yes, it works. When I push start, yes, it works. And then we need to create the program for test with the EMDR08, right? I will use the Q0, sorry, 8.0, yes, connect to another relay. So I will offline first. And then I will start from network number 2. So I will insert the push button, start M2, M0.2, stop M2, M0.3, and I will hold the signal. So this one should be 8.0, right? Q8.0. It is the EM. Yeah, this one. We connect from this EM terminal. Then I will hold signal by Q8.0. Yes. So this one start M2 from HMI, and this one stop we can write stop M2 from HMI. Yes. And then we can save the project, and then we can download to the PLC. Yes. And we can online to see the status. Yes. So we need to create text in the TIA portal, right? For start and stop command from the HMI. So let's go to text. And then I will copy and paste. So this one should be start M2. This one should be stop M2. And this one should be M2 status. So I will change address to be M0.2, and this one M0.3, and this one should be 8.0, right? Okay. And then we can save and go back to the root screen. And it's very easy. We can copy the platform here. No need to create again. Just copy and paste. Select again. Right click, copy, right click and paste. And we can add one more, paste. We will got 3 motors. Yeah. We got 3 motors. So this one motor 2, this one motor 3, and then I will go to create more program. So this one start from M0.3, right? So I will start from M0.4, M0.5, and example I will use Q8.1. It is the EM also, right? And I will host it now by Q8.1. Yes. So start M3 from HMI, and this one stop M3 from HMI. Yes. Then we can save the project, then we can download again. Okay, start the CPU, and we can online to check. Yes. So I will create M0.4 for start command of model M3. Basically, we can copy here, copy and paste, change this one to M3, change this one to M3, change this one to M3 also. So this one M0.3, sorry, 0.4, and this one M0.5, and this one Q0.1. Yes. Okay, good. Then we can go back to root screen to design and configure the push button and another graphic. So I will adjust the align a little bit. Okay, like this. Okay. So model number 2, we can go to events and then change this one to be stop number 2, and then this one events start model M2, and for the status go to visibility M2, and this one status go to apparent and change this one to M2. Okay, and for model M3 you can go to stop M3, or this one should be changed to M2, change to M3, this one should be M3, this one should be M3 also. Yes. Then we can go to events, change this one to stop M3, change this one to start M3, change this one color animation visibility, and change this one to be M3 also. Yes. So finish. Then the content here we can also insert. We change the color to be, go to property and change the color to be this color, and then I will choose the text. Basically we can copy from here and paste. TIA Portal version 17, create the button, create the screen for control motors, and then I will change the font size to be 1525. And then change the color to be yellow. Okay, we can save and then go to simulation. Okay, and then we can go to see the status. Yes, when I start motor M1, yes, let's see. When I start motor M2, in M2 start running, and when I start motor M3, yes, M3 will run also. Yes, so I will show the status on the PLC. Let's see, the PLC is turned on the output, both the CPU and EM, right? So if I push stop the EM first, yeah, relay turn off, pull out this one, yes, and stop this one also, yes, start again, yes, so it worked perfectly. So this is just example about how to wiring the PLC S7-200 Smart CPU SR20 with the EM DR08 that has 8 bits of digital output, and we can create the TIA Portal screen to test, yes, stop and start the relay control for the control the motor. If we would like to control the motors or some electrical devices, we can connect from the relay control, and then the process will working perfectly. Okay, so thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the software GIA Portal V17 connect with SIMATIC PLC S7-1500 with the Profinet port. So here is the HMI simulation with the control motors. Totally we have 3 motors, motor 1, motor 2, motor 3 and motor 4, and we need to start and stop this motor step by step. Okay, so in this section I will detail about how to create the hardware configuration of CPU module, digital input module, digital output module, and we will follow the part number of this module. Okay, and we will create the simulation project with the HMI, yes, by using the SIMATIC WinCC runtime for simulation, yes. So TIA Portal version 17, it will provide us with the PLC program and HMI also. Okay, so let's go to create the new project and then create the PLC program and HMI screen to simulation to start and stop with the real PLC. Okay, so let's go. Okay, here is the GIA Portal version 17 that I already installed in my PC. So first let's create a new folder. Example control for motor. And then open the GIA Portal version 17. Yes, double click to open. So wait a moment for open the project. Okay, so let's go to create the new project here and put the project name, example for motors, and then browse to find the folder that we already created on desktop. This project is created for control the motors, and then click create to create the project. Okay, and then go to project view. and we need to create the hardware configuration, right? So let's go to add new device, double click, and go to controllers and go to SIMATIC S7-1500, and then go to the CPU to match with my PLC. Yes, so my CPU is ES7-521-1BH, sorry, SIMATIC S7-1500, (515) 2AM02. Yeah, click here and then click OK. So wait a moment for create the hardware. Yes. Okay, go to setup, or we need to go to protect. We just uncheck the box and then go next again, and we need to full access, no protection, and then click finish. We will got one CPU, yes, here, and then we can property to see the CPU property. Yes, so we have Profinet port, 2 Profinet ports. Yes, for port 1 is 192.168.0.1, and for port 2 192.168.1.1. Yes, it is the IP address of the Profinet, and we need to add the DI, DO, and DI, right? Follow our slide. So the first one is DI, digital input module. So ES7, 6ES7, 1BH00, right? So I will go to DI and then go to 16 bits multiply 24, yeah, 1BH00. So drag and drop to the rail. Yes, and next it is the digital output, right? So 1BH01. So I will go to DO, DQ, and then go to 1BH01, right? This one. Drag and drop to the rail again. And the last module is 1BL00. It is DI, right? So I will go to DI again and go to 1BL, right? Here, 1BL00. Yeah, this one. So drag and drop the module to the rail also. Okay. And we can go to check the address of the digital input module. The slot number 2, it will start from I 0.0 until I1.7. It is 16 bits. And for digital output, it will start from Q0.0 until Q1.7, also 16 bit. Okay, so digital input, digital output module and CPU, we already create the hardware configuration. So we need to download the hardware configuration to the real PLC, right? So let's go to compile the project. Yes. So waiting for compiling the project. Okay, no error occur, and then we can save the project. And we need to set the IP address of our computer, right? Because here is the PLC IP address. (192.168.0.1). So I will set my my PC to be 192.168.0.253. Yes. And then we can download the project to the real PLC. Okay, and then choose the correct Ethernet port, Ethernet driver. And then choose try all interface, this. Start search. Okay, right now it detects one CPU, 192.168.0.1. The device name is PLC_1 and the CPU name is CPU 15152PN. So click load to load the project. It means that download the hardware configuration to the PLC. Okay, and then we can click the consider as trust the certificate. Click yes. Okay. And then the hardware configuration will load to the CPU. Continue without synchronization. Stop the CPU to load the program. Okay, and then click finish. Okay, good. So right now the hardware configuration is already downloaded. So next step we will create the function block to start and stop this motor. Yes. Okay, save the project. Okay, so we will create the function block to control these motors. Yes. So to create the function block, first let's go to program blocks. And then insert the new blocks. Yes. So add new block. Double click add new block. And then put the block name, example motor CTL, yes, motor control. And then choose the data block, function block, yes, choose function block and then click OK. And then we will put the parameters for this block. So wait a moment for create the new function block. so take time a little bit more. Okay, so we will create the motor control function block here at B1, and then we need to assign the parameter with the input and output to the block, right? So for input I will put start, it is boolean, right? Okay, stop boolean also, start, stop, overload, yes, start, stop, overload, reset alarm, right? Start, stop, overload, reset alarm. And for the output we have drive, it is command start to motor, right? Command start contactor or command start to relay. And for the alarm output, we can also generate two output to show the lamp or to show the ZN, and then show the motor overload. Yes, so I will put false. Yes, it will generate false when motor overload. Okay, and then we can create the block. Yes, so first let's choose the NC for stuff. Okay, so drag and drop the stop command here. And then choose start. Sorry, NO start. And also coil, right? Use for command start. So drive. And then I will hold the signal. Yes. Hold the signal with drive. Okay. And when motor fall, yes, I will let the motor trip also. Yes, so I will use wall to cut the motor. So motor will trip when motor fall. Yes. And for this network, I will command as start and stop command. And this network I will command as when motor overload. Okay, so when motor overload, drag and drop the overload, and then I will set the fall, yes, to generate the fall to digital output. So let's go to bit operation and then drag and drop the set coin. Yes, so I will set fall, right? When overload, motor is fall, and then this one we can reset the alarm, right? When motor is not overload. So when motor is not overload, NC, so we can reset alarm. Sorry, NO for reset the alarm. And then I will use reset coil. Okay, so this one when motor is not overload, yes, and then we can reset alarm. So we reset fault, right? Okay, so that's all for logic to control the motor, start and stop and overload. So this one reset alarm command, reset fault command, and then save the project and we can compile the block, have error or not. Okay, there is no error occur, right? So we can close, and then we need to call this function block to use on the OB1, right? So open OB1, and then we can call, yes, I will call motor control to the network. Yes, this one example motor 1. Yes, okay, so we can get like this if we call this block to use, and we have totally 4 motor, right? 4 motor. So this one I will put motor 1, and then here I can put M0.0. If we would like to use the hardware, example use the I, yes, input from the push button hardware, we can also use, right? So right now I will put push button from the HMI, so I will use M0.0, M0.1, and motor overload I will put I 0.0, and reset alarm I will use M0.2. Yes, because we need to reset the fault from the HMI also, right? So I will rename the tag here. M1 stop, sorry, M1 start, M1 stop, M1 overload, M1 reset fault, right? And for the output, I will use the digital output. Yes, we can check the address here. It will start from Q 0.0, right? Here Q 0.0, yes. So we can start from Q 0.0. And alarm I will set with Q 0.1. So we can connect to the lamp or signal fault on the control panel. Yes. This one should be command on contactor M1, right? Or we can write as M1 right? M1 contactor This one M1 fault, right? So M1 fault. Okay, and then we can save, and then we can compile. Okay, there is no error, right? So we can do with the model number 2. Yeah, just drag and drop the model. So I will put model 2 and then drag and drop the function block. Yes, here we no need to create more, right? Just drag and drop to use. And then this one I will put model 2 dB. Yes, and we can put this one start from M0.3, right? So M0.3, M0.4, I0.1, reset alarm M0.5, and this one will start from Q0.2, Q0.3, yes, and this one start M1, right? M1 start. So M2 start, M2 stop, M2 overload, M2 we will put M2 reset fault, right? M2 reset fault, yes. And this one M2 dry or M2 contactor, M2 fault, yes. Okay, and for model 3, yes, because it's very easy. When we create the function block, we create only one time, and then we can copy, drag and drop to use. So I will drag and drop for model M3, and this one I will put M model 3, yes. And then this one will start from M0.6, right? M0.6, M0.7, this one I0.2, M0, sorry, 1.0, this one Q0.4, for Q0.5, yes. And this one we can also rename the tag as M3 start, okay, M3 stop, M3 overload, M3 reset fault, M3 contactor, M3 fault, yes. And then for model M4, it is the last one. If we have 10 or 100 model, we can also create like this by using only one block, because the style of block is the same, yes. So I will create last one for model M4. It is just example, yes. So if we know about the basic example basic, we can also create anything. Yes, so I choose example only for motor. So this one should be M1.1, M1.2, I0.3. Reset I will choose M1.3, and this one I will use Q0.6. For fall I will use Q0.7. Yes, and we can rename. So this one M4 start, M4 stop, M4 overload, and I will put the example project on the video under my video description, so we can download and then see the example. Yes, everyone can use my project. Yes, so M4 reset fall, and then this one M4 contactor, M4 fall. Yes, so that's all for create the blocks for motors, and then we can save and compile the blocks. Okay, there is no error, right? And then we need to create the faceplate, create the screen to control the motor, right? So we can go to device configuration, we can go to add new device, and then go to HMI. I will use TP700 comfort HMI. Click OK. So wait a moment for create the HMI, yes, to control the motor. Okay, click finish. Okay, wait a moment. It takes time a bit. Yes. Right now, we already created the screen, the root screen. Yes. And then we need to create the connection, right? The first we create connection. Go to the connections and double click and create the new connection. So I will create PLC S7-1500 device. Yes, and then I will choose here S7-1500. Okay, I will choose the Ethernet because we connect with the Profinet port of PLC from the LAN port of our PC. Yes. And then here is the IP address of our computer. So I will put IP config or we can put the manual IP address of our computer. Go to check the manual. Okay, 192.168.0.253. Yes, so I will put 253 here. And here is the IP address of our PLC. So 192.168.0.1. It is correct. And then we need to create the text. Yes, so HMI text. So our text. Yes. So we have start, stop, overload. Yes. So one order we have 6 texts. So we can go to create the text. Example M1 start. The data type is Boolean, so I will choose Boolean. And then we use the external, we use the PLC device, right? So I will choose connection and choose the PLC device. And we have PLC text. And then I will choose M0.0, right? Because the start command. And we have M1 stop. Address M0.1, that's correct. And then we have M1 overload, right? And then I will change with the I0.0 M1 overload. So I will change from M to I0.0. And then we have M1 reset fall, right? M1 reset fall. And the address is M0.2, yes. So choose M0.2. And we have also M1 contactor. Q0.0, right? And we have M1 alarm Q0.1. Yes, that's correct. So we can also copy and paste for M2. Yes, and we will go like this. So I will delete this one. So this one should be M2 start, right? So we just put M2 start, M2 stop, M2 overload, M2 reset fault, M2 contactor, and M2 alarm, right? And we need to change the address also. Yes. So this one M0.3. Yes, to match with the blocks, right? Block number 2 start from M0.3 is start, M0.4 is stop, I0.1 is overload, M0.5 is reset fault, Q0.2 contactor, Q0.3 is fault. Yes. So we can copy for model number 3 and then paste. So we can rename as model 3 start, model 3 stop, model 3 overload, model 3 reset fault, model 3 contactor, model 3 alarm, and we can change the address. Yeah, don't forget change the address. Otherwise model 3 and model 2 is the same address. Yes. So this one will start from here. So this one should be M0.6. Yes. Start from the block number 3, M0.6, M0.7, I0.2, M1.0, Q0.4, Q0.5, and we will copy for model number 4. Yes, so we can select, copy, and then paste. Rename this one to be model 4 start, model 4 stop, and then model 4 overload, model 4 fault, reset fault, motor 4 contactor, and motor 4 alarm. And then we can change the address. Yes, don't forget change the address. For motor start, it should be M1.1, right? 1.1, M1.2, I0.3, M1.3, Q0.5, sorry, Q0.6, and last one Q0.7, right? Okay, right now we already created the text for model number 1, number 2, number 3, and number 4. Yes. So we can save, and then we can compile the text, compile the project. And let's see the result. There is no error, right? Should be no error. Yeah, no error occur. And then we can go to create the HMI, right? So I will put the background to be this color, and I will put the title. I will change color too. Yes. Okay, this color also, and I will use the label. Yeah, tick. So GIA Portal version 17 create FB, yeah, function block to control motors. And check the fit to size, and then I will change the color to be this color. And for the text format, I will choose central. Okay, like this. And then I will use button start and copy for stop. And paste one more for reset alarm, right? Okay, I will put here. And this one should be reset alarm. Yes. So here I will put the background to be I will use solid, and then choose blue color for start. And the text color I will use black. This one also I will change to solid. And background I will choose red. And change to color the text to be black. And this one also I will change to this color. And change the background, the text to be black also. Okay. And I will insert the motor 1, yes, from here. We can choose another style of motor that we want, yes. So I will choose this color, yes, for motor 1. And I will choose the status of the motor, yes. When motor run, this one should be green, right? So go to property and then go to change the color to be red. Yes, motor not run is red. And then we can put the text motor 1. Yes. And also we can put the text when the motor run is run. So running here. When running, I will change to the green color. Yes. Okay. And we can align. And then we can copy for motor number 2, number 3, number 4, right? So we can select, right click, copy, right click, paste. Motor number 2. And one more paste for motor number 3. One more paste for motor number 4. Yes. And we can align to be center of the HMI. Okay. And I will change this one to motor 2. Motor 3. Motor 4. And then we can configure the push button start, stop, and alarm, right? can compile to see the error or not. Okay, there is no error. So push button start, go to events, go to please and choose the function. Yes. We can use set bit while key pressed and then go to take default take table, and then we can drag and drop the take from the default take table. So M1 start, yes, and for stop we can use also set bit while key press and stop. And for reset alarm we can also use set while key press and then drag and drop the take, right? And also here for M1 status we can go to color animation, go to display, add new animation, apparent, and then we will use M1 contactor, drag and drop, and change this one to 1 and change the color to be green, right? Okay. And for running we can go to color animation also and then choose visibility, drag and drop the text and rank from 0 to 0, right? And choose invisible. And we have also the motor alarm, so I will copy this one. So when motor alarm, I will put the color animation and then put the apparent. This one we should delete, right? Okay, so for the motor alarms or motor overload, we can use the blink, yes. So let's go to the HMI text. Okay, and then go to the motor 1 alarms or motor 1 overload. Yes, M1 alarm. And then I will change the field to be this color and also blink. Yes. And then we need to add more for the visibilities. When motor not alarm or motor doesn't overload, we no need to show this screen, right? So we can go to apparent, go to new animation and add visibility, and then we choose M1 alarms, rank from 0 to 0, and then invisible. Okay, and for model M3, M2, M3 and M4 we can do the same as this model 1. Yes, so we can go to events. This one use freeze, right? Free and use the set bit while key freeze. So go to freeze and use set bit while key freeze, and then choose the M1. We can type here also M1 start. Yes, and this one use set bit while key freeze, M1 stop, and this one we use the reset alarm, right? So set bit while key freeze, and then choose the M1 reset alarm, M1 reset fall. Yes, the same as the M2. Oh, this one should be M2, sorry. Our take is M2. M2 start, M2 stop, M2 reset fall, and this one we need to show the M2 condition, right? So go to color animation, add new apparent, and then choose M2 contactor. Yes, and we can put the field when condition 1. I will change to green, and this one also when the motor running I will show it. So M2 contactor rank from 0 to 0, and then invisible. Okay, and for the M3 we can start from the top. So apparent. Oh, this one need to put the alarms also, so I can copy from here and then paste, and change this one to be M2 alarm. Yes, and this one also we can use M3 contactor, and then when the condition 1, then I will change to green, and this one visibility also M3 alarms 0 to 0 I will change to invisible. And for the start, let's go to event, please set bit while key freeze, M3 start, this one freeze, set bit while key freeze, M3 stop. Yes, and for reset alarm, set bit while key freeze, and then M3 reset fall, right? Okay, and I will copy one more for model M3 alarms. So we just change this one to M3, and this one M2. Yes, so M1, M2, M3. Yes, then for the last model M1, sorry, M4, I will use the add apparent, and then M4 contactor, change condition when want, I will change to win, and for the running I will add new visibility M4 alarm, rank from 0 to 0, invisible, and for start go to events, please set bit valve key, please M4 start, yes, and for the stop the same, set bit valve key, please M4 stop. For reset, set bit valve key, please M4 reset fault, yes, and then copy this one, copy, and then paste, and we just change the visible to be M4, yes, and this one change to M4 also, this one should be changed to M3, and this one should be M2. Okay, that's good, because we need to change the color also when it pop up, color with blink, then we can drag and drop here. Yes, and I will put the peg, I will put the background a little bit for easy to see the motor status. Okay, I will put like this. Then I will send to back, order, send to back, and then we can adjust. Okay, we can align to be center. I will align the motor to be center like this. Actually, we can design the style, another style that we want, yes, because it's very easy to design for TIA screen. Okay, then I will change the background, go to property, go to property, and then I will change the background to be this color. This one I would like to change to be yellow. Adjust the font size to be 21. Center also. Okay, and then we can copy for model number 2, number 3 and number 4. Yes, so I will delete this one first to be the same format. Copy and paste. And then send to back, right? Change this one to model 2. And then we can adjust the align of the button. Okay, and model number 3, we can copy and then paste. And I will send this one to back also. And we can adjust the motor to be smaller than this one. Yes, we can adjust the align. Okay. Then this one I will change to model 3. Okay, and then copy one more for model 4, copy and paste, and then send to back also. Then we can adjust to be good looking. Okay. So this one should be model 4. Yes. Okay. Then we can download the program to the PLC and then online, and we will test together. Okay. Okay, so right now we already config the screen. Then we can go to the hardware PLC and then we can download. Yes, I will compile again before download. So compile the program again. So wait a moment for compile the program, and then we can download and see the result together. Okay, compile successful, there is no error. So we can download the hardware configuration and blocks to the PLC. Okay, I will load the program and then finish. Okay, let's go to check the blocks. Program blocks OB1. And then we can go online. Because we already connected to the PLC. Yes. Okay, so we successful online. And then let's go to the HMI and then we can compile again. Okay, there is no error occur too. Then we can simulation. Okay, so we can test with the program. Yeah, I will put like this for easy to check. Okay, so right now I will start the motor 1. Yes, so right now the output is off, turn off. So I will start. Okay, when start the motor 1 will true. Let's see, Q0.0 is turned on, and the signal show the motor is running. Okay, and then I will show on the PLC status. Okay, let's see, the output is turned on. Then if I stop, yeah, the output is stopped. I run again. Yes, it run. I start motor number 2. Number 2 is turned on. Number 3 turn on, and number 4 is turned on also. So if I push the alarm, let's see, alarm, because I parallel the alarm with the I/O. Yes, so alarm will show 2 motors, and this is alarm motor number 4 and number 3. Yes, so motor is alarm. Then we cannot reset, right? Because the alarm, example, overload or something. So I will release the alarm, and then we can reset the alarm before start. Then we can start again. Yes, motor running again. Okay. So if we would like to add more the function, example, the motor overload or motor stop, we can add also. I will show. Let's see, all block is true output because we start the motors. True, this one true. So let's go to root screen, and then let's copy this one and paste. Yes, so this one we can write stop, and then we can change the color to be red. Yes, and for the motor stop, we can put like this. So I will put animation, and then go to display visibility. So when motor 4 is turned off, contactor turned off, then I will set invisible. Okay, let's simulation again. Yes, so when I stop the motor, let's see, motor will stop and the signal so stop when I start again. Yes, so we can copy to all motors. I will copy and paste here. And just change the take, go to animation, and change the take to be motor 3. Visibility, yes, visible, and then pass one more here. And this one should be motor 2, right? So animation, change to motor 2, and paste one more. For motor 1, right? And then change to motor 1. Yes. And let's simulation again. Okay. So 3 motor is running and 1 motor is stopped. Then if I stop motor 1, yes, let's see here, it shows stop. I stop motor 2, it stop also. I stop motor 3, it stop also. Okay. Then if I run again, let's see, running. And one more thing, if the motor alarm, let's show the overload, right? So I will copy and then paste. So it will show overload when motor alarm, right? Overload. Then I will change the color to be here. Yeah, this color. And then let's go to animation and change this one to be M4 overload or M4 alarm. Yes. So 0 to 0 and invisible, and then go to color animation, add new. So when M4 alarm, then I will change the color to be this color and should be blink also, right? Okay, let's test. I will copy and paste here. So we can go to animation, change this one to motor 3 alarm and invisible motor 3 alarm. Rank from 0 to 0 invisible, and then paste one more. Yes. Animation, change this one to motor 2 alarm and apparent change to motor 2 alarm also. Okay. And one more, we can paste. Go to apparent, go to visibility, change motor 1 alarm. Apparent, change this one to motor 1 alarm. Okay. Then we can save the project and then simulation again. Okay, so right now all motor is running. So let's go to OB1. Let's see, motor 1, motor 2 is running. Then we can simulation. I will push the alarm. Let's see, motor will show overload. Okay, I push the alarm. Let's see, motor 1, motor 2 overload. I push one more. Motor 3 and motor 4 is overload also. Okay. Then I release the alarm. Then we can reset the alarm. And we can start again. Yes. So the animation we can do everything if we know about the function to use. Example, visibility or visible. So we can show or we can hide the object the same as we want. Okay. So this is just example about how to create the function block to control the motor by using the TIA Portal version 17 connect with the PLC S7-1500. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to say I'm sorry if I have mistake in this video, and I would like to request all of you to like, share and subscribe my video also to get more notification and more new video that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye.